Hi everybody, Captain Al speaking with Ftd Pc-Fs 2, the flying portion of it. And we're going to get started with FTD number 2. Remember in FTD number 1, we pretty much did the flight deck preparation and talked through everything. So today that's going to go much quicker. So we'll start with the electrical power-up procedure. And remember, that's a read and do from your flight crew operating manual. That would be in the supplemental section again. I think it's 6.1. So we'll turn the battery switch on. Standby power to auto, demand pumps off. Windshield wiper selectors off. And if the brightness was down here, we could turn that up. Alternate flap selector off. I like to check the arm switch, it's also off. Landing gear lever is down, it indicates down. And the flap handle is up, and the indication shows up as well. Come back over and check the bus tie switches are all in auto, which they are. They should be. 100% of the time they are. And then we can establish AC power using external or the APU. We'll go ahead and select external power 1. That'll bring everything to life. And we'll assume again we're on a freighter. We have the freighter configuration still, so we'll just select external power 1 for so we keep the main deck handling bus powered. Then we'll start the preliminary pre-flight procedure. We'll bring the IRUs to nav. We can come over and check that the align messages show if we want. You don't have to. But you'll see here after 20 seconds or so, you get the IRS align mode left, center, and right. And the countdown starts from, at this latitude, about 10 minutes. Generally, we think of it as 10 minutes alignment process. On the ND, of course, you can see that it starts at 7 minutes and then counts down from there. We'll go ahead and check our status page. While we're here, we could check our engine oil quantity. It's sufficient for the flight. We said we were going to use 20 quarts as a minimum. And again, that's just our, let's say, our airline standard. Again, each operator is going to determine what the minimum oil quantity is. Boeing doesn't specify one. And then we'll go to the status page and we'll check for status messages. We do have a couple here, but they're going to go away when I turn on the window heat. So as far as I'm concerned, this is clear for now. Check the hydraulic quantity, should be above 0.75. Otherwise you get a little magenta RF. And they are anything up around 0.95, 1.02, 1.05. Anything in that range is good. If it were down to 0.80, I'd probably want to know why if one of these was down. And then the oxygen pressure for the crew and for the passengers is good, up at 1800 psi. I'm not going to get worried about that unless it drops significantly and I see something less than 1,000, then I know I got to get it serviced. But if it were dropping down to 1,400 or 1,200, again, I'd want to know why, because that's not normal. I'm used to seeing 1,800 here, so if it was less than that, I would check. Then we'll go ahead and check all our emergency equipment. So we check, the crash axe, life vests, PB, smoke goggles if you have them, escape reels, overhead hatch, anything that's on your airplane. You would check as far as emergency equipment that's on the flight deck. And then we'll recall our messages because we want those up there when we when we check the when we do the first officer setup. We want those displayed. So kind of go back to a configuration here if you look at something else, or you're going to check it later on. While I'm here, I can see the CDU brightness is down here, so I'll turn that up. And then after we check all the emergency equipment, we'll check the P6 circuit breaker panel behind the FO. All the circuit breakers are in. And again, all the stuff we talked about last week, you could take a flashlight and check these if you're actually in the simulator of the airplane. And then the overhead maintenance panel, just go ahead and make sure all the guards are closed. All the discrete lights are out, with the exception maybe of this SSB, but in this case it would be out because we have one power source which is external 1, and the SSB would be closed in that case, so the light would not be illuminated here. But if you're on a passenger airplane, it'd be very common to see this light illuminated. And we'll check that the APU start source is an APU battery. We'd prefer it there as far as the APU start source for it. And again, we don't have to do the cockpit voice recorder. That's more of a maintenance function, the squibs. But again, we're just making sure guards are closed. The lucifer switch here, again, would be determined by the load that we're carrying in the belly, in the lower lobes. And that would be determined by the load master as far as what it should be on. We'll come over to the P7 circuit breaker panel, check the smoke vent handle is in, check the circuit breakers on the P7 panel, and then if we're going to be checking the brakes, the brake wear indicator pins, we'd set the parking brake, and in this case the parking brake is set. And I think that should be it for the PPP, the preliminary pre-flight. Then we'll go ahead and set up our CDU pre-flight. And again, I'll assume that the FO is doing it, or the captain could do it. Remember, either one could do it, or whoever's the pilot flying. It just determines by the crew who does it. And again, it comes up on the menu page, so we're going to go to FMC. We'll check the model, the engines, the nav data. Again, some airlines check this. We won't check it because there's nothing for us to check here, but some airlines will check the first 3 characters here to determine if it's their database that's in there. All we need to do is check the model, the engines, and the active nav database is current. In this case, it's January 23rd, and so this nav database is current. The inactive one is not current. Everything else we really don't care about. Position initialization. So on the pause init page, we have the reference airport, which is KBFI. We'll type that in for reference. We'll compare the reference airport with the GPS position, and they should be reasonable, and they are. Obviously, the GPS position is very accurate, so we're going to use that for the set IRS position. So line select it in the scratch pad into the boxes. UTC time is correct. It's 11:12. Actually, that's off a little bit. 1832. But I have 11:12, so that should be. Yeah, that's not right. We'll check that. So the set IRS position will eventually be the last position when the IRUs align. Next, we'll go to the route page. We'll put in our origin airport, which is KBFI, Boeing Field. And then our destination airport is also Boeing Field, so we'll put that in. And then our flight number is going to be, we'll call ourselves Sonic 44 again, or Sonic for subsonic flight training. Again, that's going to go to different areas depending on who needs our airline identifier and our flight number. It customizes the pages. And then our first waypoint is Orton. So we'll type out Orton. And again, that goes on the right side. Waypoints and nav aids on the right side. Again, same waypoint, so we'll select that. And then after that is VAMPS, Victor Alpha Mike, Papa Sierra. We'll put that on the right side. It will default to direct since you're not telling it an airway to get there. And then after VAMPS is direct to pane, Papa Alpha Echo, which is a VOR. And again, nav aids go on the right side as well. Again, if we don't tell it anything else, it will default to direct. In this case, it's going to ask us which pane, and we know it's the first one because this is in the southern latitude and this is in the eastern longitude. So obviously these are way far away. And the first one is the one we want. And again, you can select it here or here, it doesn't matter. And then after that, it's Victor 23. And now we have an airway, low altitude airway. And then we have boxes because it's asking us where, and we're going to go to Seattle, VOR, which is SEA. And then if we anticipate, depending on whether the Kent 8 departure, we said the current one is Kent 8. If the Kent 8 departure is part of our flight plan, we would put it in at this time. In our case, we don't have it as part of our flight plan, so we wouldn't put it in yet. Now, if we get it with a clearance, then we'll put it in then. From here, we can go to the departure page. Now we want the departure for Boeing Field. And we want runway 14 right because we're anticipating that's going to be the runway for departure. It could change if the ATIS changes. But we probably have a pretty good idea what the runway is for departure. We can always change it or modify it as necessary. We'll go back to the route, and you can see the runway is put in. If we go to the next page, you'll notice there's no connection between the runway and your first point. And that's what we want in case we're flying a runway heading for vectors to Orton. So for right now, that's good. I really don't want a connection there between the runway and Orton. And then we got direct VAMPS, direct pane, Victor 23 Seattle. And that matches what we have on our paperwork that you Patreon members have. And if we're all done with that, which we are, could activate and execute that. When you activate it again, you get the execute light erase prompt and nothing here because it's an inactive route still. Again, you'll notice the blue dashed line is an inactive route, a dashed white line is a modification to the route, and the solid magenta line is an active route. So once I activate that, or execute that actually, it's going to then become an active route. And the blue dashed line and the white dashes will go away, replaced by the magenta line, indicating that we now have an active route. And also route 1 will become active route 1. So go ahead and do that. You'll notice it's a magenta line now, and in this portion that's going from Payne up here down to Seattle. And then this is the portion from, this is VAMPS to Payne here. We'll copy that into route 2 just in case we need it later on. And we're done with the route for now. We'll go to the perf-init page and we'll put in our performance information. 480 is the zero fuel weight. Again, we're working in pounds here. We'll pick some lessons where we do kilos, but for right now it'll be in pounds. 480, 150, 630. So 630 is our gross weight. These are preliminary figures. We can also change. We can change them if they change with the final paperwork that we get for weight and balance. But we usually have something in our package that shows our preliminary performance numbers, and again, that could change based on if the load changes. So reserves 20,000 in pounds. Cost index, we have 100 on lesson 2. Yep. And then the cruise altitude, we said, is going to be 1,000 according to our paperwork here. Our flight plan, our made-up flight plan. Step size, we'll use 2,000 for RVSM type airspace. Thrust limit, we said we're going to use TO2. We're going to change what's on the flight plan to modify it to TO2. Just better to slower things happen. You can see the takeoff a little bit better with slower things that happen with a reduced power. And we certainly don't need full takeoff thrust with this kind of weight. We're at a mid-range weight. And that's all we need here. We'll go to takeoff page, and we want flap 10 for takeoff. That's what our performance shows. And we'll put a slash in there, and our acceleration height will be 1,000 feet. We're using NADP2 again. So 1,000 feet. Don't have to type that in, but it makes it big and it stands out. Engine out, we're going to use 1,000. We're going to say that's what our airline requires for this airport is 1,000-foot engine out acceleration height. And the thrust reduction NADP2 will be flaps 5. And again, I just want it to stand out, so I'm going to make it big by typing in 5, putting it in there. And now everything is full caps here. And I'd rather have full capital letters just because it stands out. There's no down slope. There's no tailwind, so I don't have to put anything here. Even if I had a headwind and an upslope, I wouldn't put it here. This is more conservative, not taking the credit for that. But if I had a tailwind or a downslope, I would take it. Runway's dry. V-speeds are in there. We don't have a CG yet. This is our preliminary numbers, so we're going to leave it just like that. So this is the overhead panel for the FO. We're going to do the cockpit setup here, and the guard closed. The LT is armed. EEC switch is normal. The alternate lights are extinguished. The IRUs are in nav. Standby power to auto. Utility bus switches are on. The off lights are extinguished. We'll go ahead and start the EPU at this time. Hold it for a second. Release it. Don't let it spring back to on. And then it'll take, about 60 seconds or so for the EPU to run. I don't have to monitor anything. I could if I want to, but it's not necessary. You have an APU controller that will monitor the start and shut it down if there's a problem or a fire or anything like that. Bus tie switches are in auto for now. The isolation lights are extinguished. Generator control switches are on. The off light is illuminated. The drive disconnect switches, the guards are closed, they're wired, and the drive lights are illuminated. The APU's up now, so I'll go ahead and select APU generator 1, APU generator 2, and I'll do that just well ahead of time in case there's any spurious status messages that would show up. So I certainly don't want to wait till last minute to change to APU. Depending on how long I'm going to be on the ground, I could wait to do that. But for training, we'll select it right now. Notice I do have APU generator 2 on now because external power 2 is available. That's powering the main deck cargo handling bus, so they can still continue to load. Now, if they were going to remove external power early for some reason, then I'd have to probably take this off again. But for right now, we're still plugged in with external, so that's good on the main deck handling bus. Again, the hydraulic system fault lights illuminated, the demand pump pressure lights are illuminated, the demand pump selectors are off, the engine-driven pumps are on, the pressure lights are all illuminated. Storm lights as desired, we'll have them off. Circuit breaker overhead panel, glare shield, and dome lights as desired is daylight, so don't need too much there. Again, notice from the generator control switches on down, you have all lights in the switches. And from the bus tie switches up, you have no lights, except for these external power and APU lights. But otherwise, there's no lights in the switches. No lights here, no lights in the battery, no lights in the utility switches, no lights in the EEC. It's just a good check, that kind of this is the halfway point, and everything down here has lights, everything up here has no lights. Fire overheat test we don't have to do, that's a maintenance function. We'll close the guard, that arms the emergency lights. Normal, service interphone, cabin interphone off, field main transfer is blank. It's a momentary action switch, guard closed. Push the fire switches in, make sure they're in. Push the APU fire switch in, make sure it's in. No discrete lights illuminated. The cockpit area microphone looks good. Condition is good, nothing damaged there. The main cargo compartment forward and aft lower lobes switches are off. The momentary action switch here is out, and the guards are closed, and no lights are illuminated. Start switches are all in. We just push them to make sure they're in. Standby power is normal. Continuous ignition is off. Auto ignition selector is single, and the auto start switch is on. It's operating today. The fuel jettison panel is off for the controller, and the nozzle valve switches are closed, and the guards are closed as well. Fuel panel, all the crossfeeds should be open, so we're going to open 1 and 4. 2 and 3 should be open. There's no reason why those should be closed. These could be closed because the previous crew was in tank to engine when they returned, and now we're going to open them in preparation for engine start. So all cross feeds open, all fuel pumps off, and we make sure they're all off, and pressure lights in main tank 1, 2, 3, and 4, except whatever's the APU is using, in this case main tank 2 aft. Newer airplanes, it could be main tank 2 and 3 aft, depending on what configuration you have when you do your setup. The cell anti-ice switches are in auto, or you may have the push button switches, in which case they would be off. But in my case, I have the auto position, or the auto selectors here, so I'm going to just make sure they're in auto. Wing anti-ice is in auto. Again, if you have the alternate action switch, you would just make sure it's off. Window heat, we're going to turn that on, and we'll check the status messages that they went away when you turn that on. The wipers are off. We can check them again. The washer fluid is off. This is a spring-loaded switch, so it should be off. These are deactivated for the rain repellent. Lighting, again, we'll check landing lights off, both outboard and inboard. Turn-offs off, taxi off. Supernumerary, guard closed. Upper and lower yaw damper, that's on. And the light should be extinguished here, which is the your off lights in the switch. Once that first IRU enters the nav mode, these lights go away, which doesn't mean it's operating. It just means it has IRU input. That's all it means. You need hydraulics and you need to be airborne before the yaw damper actually starts working. But it's a step in the right direction in the sense that the IRUs are in the nav mode and the lights would extinguish at that time. Landing altitude switch should be in auto. We'll check it when we get down to the EICAS. We're not going to mess with it now. The outflow valves should be open. You want to check that they're open. And the auto switches should be in the auto position, which is not on. On would be manual and off would be auto. So we're making sure those are in auto. Spring loaded to the middle here, and then the auto selector in normal, and then it'll select A and B on an alternating flight basis. Fan would be as desired if we need it for the flight deck on the ground. Temperature selectors all in the 12 o'clock position, or 11, depending on the airplane. You're going to know kind of what setting to probably set in terms of getting the best cooling. But generally we start out with all in the 12 o'clock position. Then you could, go from 11 to 1 o'clock depending on experience and what the airplane will set as far as temperatures go. Zone reset switch should be out. That's a momentary action switch. Trimmer switch should be on. The equipment cooling should be normal. The high flow switch should be off. The aft cargo heat should be off. Packs we can turn on at this time since we have the APU running. And the pack reset switch is a momentary action. That should be out, and there should be no light, no system fault light. Left and right isolation valves should be on, and the no light with that. And the system fault lights here should be extinguished. The APU should be on, the bleed, and all your engine bleed air switches should be on, and the off lights are illuminated because the engine bleed valve is closed at this time, and the PRV and the HP valves, they're all closed. But the switch is on, meaning it's armed, so that once you have pneumatic pressure, some of those valves will start to open up. Going down to lighting, we want to make sure the nav light's on. It probably should have been, but it's not in this case, so we'll turn it on. Normally that's left on. Beacon off, strobe off, wing off, logo. If we're at night, we could turn that on. We're not at night, so we'll keep it off. And then indicator light test. If you wanted to do a test, you could bring it to the test position. All the lights go bright. After about 10 seconds, it goes dim to the dim position. And then you'd have to look all the way through the panel to see lights. And again, you're not going to see lights in every switch. And like we talked about last week, for example, here, that little white bar indicates that don't expect to see a system status light here because there is not one. So they put a little white bar in there indicating that there's no light. Same thing here with the outflow valves. No system status light, so they put a little white line there. So you can see when I do the test, that those switches are, there's nothing there, there's no light, and there shouldn't be. But it's a way when you look through that you can see that, oh yeah, there shouldn't be a light there. From here we go down to the first officer. We'll get some panel lights on here. Oh, my mouse is in a bad position here. I got the control column set up today, but the mouse is bumping up against something that makes the panel move. I'll turn on the panel lights here. I'll turn on the interior, or the floodlight, I should say. And then I'll turn on the outboard CRT just to get the brightness up there. We'll turn up the inboard CRT a little bit. Well, it looks like it's pretty good. And so then we'll come down to our flight director switch, get that on. Again, here would be as desired. We want the EICAS messages displayed, which they are. We want the secondary EICAS displayed, it is. And so this would be as desired. Should be in baro here instead of radio, so we'll switch that to baro. We're in the States, so we're in inches. Flight path vector if you want it. Meters we don't need. Go VOR here, ADF here just to check it. We're in the map mode, that's fine. We could go if we wanted to. Let's go to plan, because I said I was going to check that. So let's go to the plan mode. Let's go to the, and let's go to the legs page down here. So you'll notice when you go to the plan mode, for those of you that don't know, it'll come up with a display that is referenced to true north. And the first waypoint, which is Orton, is displayed in the center of the ND. And this is like you're looking at a chart. If you were to pull open a chart and look at it, everything would be oriented north. And so you can see that once we go to the plan mode, we get a center prompt right here on the legs page. Let's see, you seen that? Yeah, the center prompt here. And you get a map center step prompt here. And those weren't there when you were in map. So if I go back to map, you'll notice there's no center prompt and there's no down here to move on. So if I go to plan, you get that map center step prompt and you get the center prompt here. And that allows you to basically step through the route. You can put the mileage as desired. Let's bring it up to 40 miles. And right now, Orton is in the center of the ND. If you push 6 left, or sorry, 6 right, R6. If you push R6, that'll go to the next waypoint, which would be Vamps. And then Vamps will be in the center. Vamps will move from here into the center of the ND. So when you push that, Vamps is now in the center of the ND. And then if you push it again, it'll go to the next waypoint, which is Payne. Payne is now in the center of the ND. And if you push it again, it'll go to Seattle. And now Seattle is in the center of the ND. If you push it again, it just stops, doesn't do anything. So to get it back to page 1, if you were on page, let's say 3 or 4, you could just go to the next page, and that would go back to page 1. In this case, if I push the legs key again, it'll go back to the top. And I could step through again if I wanted to. Now, stepping through the route, I don't think I mentioned this on the other day. That's why I'm taking some time to do this. Stepping through the route is good in the sense that it shows you on your ND a flight plan that shows a magenta line going from waypoint to waypoint, and it shows that there's not any anomalies in the database. So, you know, sometime every now and then you might see some anomaly that's in there that's really weird. And so by stepping through the route, you see from waypoint to waypoint that you have a solid magenta line going from waypoint to waypoint. But as far as checking your route goes, it's not satisfactory to check your route. So you would have to take your flight plan and actually compare the courses and distances against the flight plan to determine that the route is correct. And so if we had an actual flight plan, which we don't, But if we had an actual flight plan, we could actually come down here and go, okay, from Orton to Vamps, it's going to be a 012 magnetic course and it's 16 miles. And we'd compare that with a flight plan and make sure that's reasonable. This might be a degree or two off, and that's fine. The mileage could be, it's either going to be right on or a mile off, that's fine. But we're checking for the flight plan that it kind of matches with the waypoints that we're going to. And then there's specific procedures that whoever checks it will kind of draw on the flight plan, and then whoever, the next crew member that checks it, the other one who hasn't checked it will check it as well, and then make sure that all the waypoints match. And then there's ways on the flight plan that we can designate that we both checked it. We won't talk about that now, but so again, the important thing here is the Orton to Vamps, Vamps to Payne, Payne to Seattle, as far as the magnetic course and the distance between waypoints. That's what's important. The stepping through is actually less important, but we still want to do it because I'm looking that I have a smooth Magenta line from here to here and from here to here and all the way through your route. In this case, there's only 4 waypoints because we got this little round robin. And when you're done stepping through the route, you always want to go back to the map mode. And then that center prompt and that map center step prompt will go away. Okay, let's go back down here. Okay, let's see, we were up here, I believe. So we checked VOR, it's in green, ADF's in blue, that's fine. It's not tuning anything yet, that's fine. So we'll go to VOR for both displays. We're in the map mode. Range as desired, we'll go 20-mile range, that's fine. We have the full compass rose. We'll go to the expanded view here by pushing center, and I have TCAS off displayed, which I want. If it wasn't displayed, again, I can display it by pushing traffic, and then that would show TCAS off. And that way, when I go to my transponder to RATA, we'll have the transponder giving us the TCAS information in that sense. TCAS information will display on the ND then. Let's see, what else do I want up here? Airport, I want that. And again, technique, but you could have that. All these other switches are fine for now. And then from here, I'd come down to my oxygen, do my oxygen test. We talked about that last week. Can't do it with the AeroSim, or the, not the AeroSim, the AeroLinks PSX. We can't check that. But again, we go to status page and make sure the little red bar is in the 100% position, and then push the reset test lever down, see the yellow cross, and then while we're doing that, hold the emergency test button along with the reset test button, or the selector, and hear the sound of, or look at the status page, and we'll see that the oxygen pressure doesn't drop more than 100 psi while we're holding it in the emergency position and holding the reset test lever down. And then you'll hear a sound like that. And then if you're going to do the oxygen mass microphone test, then we could go to flight and interphone on the audio panel and then hold the RT switch to RT or interphone and hear the sound of oxygen flowing through the oxygen mass microphone. Again, we can't really do that, so we're not going to do that. We'll do it in the PMDG will demonstrate that, but here we can't do that. So let's go back to our engine page. Foot and shoulder heaters as desired, and then we'd come up to the instrument source select switches and make sure they are in the 12 o'clock position, which is normally the auto position, except in this case the IRS doesn't have an auto position, it just has a right, center, left. And it's in the right IRS, which is where we want it. Everything 12 o'clock basically. Nav would be in right FMC, and the flight director, flight control computers would be off the right FCC, and that's everything 12 o'clock. Lighting would be as desired, we already did that. Clock, we'd check Again, it looks like the clock is off a little bit, yeah. So I'll set that with the captain's clock. I'll go ahead and clear out the elapsed time. If I want to, check the chronograph that it works. Starts moving, stops, and resets, that's fine. We know the UTC time is not correct for some reason, but we'll go change it in the on the captain's clock. Then we'll come here to the PFD, blank Toga Toga FD, no V speeds because we have no V speeds. Display, 30 knots parked, 200 on the MCP, that's normal with no power. 360 heading, that's normal with no power on the MCP. And when you reestablish power, it'll come up 200 north and 10,000. So that's all normal. Ground speed 0, -8 on the radar altimeter. Blank Toga Toga FD, 8 degrees pitch up, wings level, no flags. The altimeter is, again, if we had the EICAS, we'd probably have an idea what it is. We could leave it like this until we have the EICAS, but in this case, we know it's going to be, what do we have on the initial EICAS here? We have a 2994. So we'll go ahead and set that now. .2994 should show approximately field elevation, which it does. And again, no flags in this display. Normal here. Ground speed 0 on the ND. I have airport displayed, TCAS off displayed because the IRUs are aligned. I don't want to move on here unless the IRUs are aligned. So if I got to the point where I checked my clock and I get here and the IRUs are still not aligned, then I'd wait until they are aligned, and then I could do the rest of my checks here. ND would be basically no flags. GPS is being used for the FMC position. 3 IRSs are being used for the FMC inertial position, and then that's going to be updated by GPS to give us the FMC position. Obviously very accurate. If GPS failed, then it would degrade to DME, and if DME degraded, then it would degrade to VOR DME. And if it couldn't find VOR DME, then it would revert to the 3 IRU positions. The 3 IRS positions are kind of triple mixed into one. That gives us the FMC inertial position. And then that FMC inertial position is updated by GPS, and that's what this is showing here. Again, nothing displayed here, but that's fine for now. Nothing's being auto-tuned. And again, range as desired. And I can just check that I have magenta lines, which I do. Again, if you want to look at your flight plan, here's part of it. Part of it's behind us. And again, I'll stay in the 20-mile range. We'll come this way. We'll go EIU selector auto. The brightness is selected here. EIU auto, heading reference normal, FMC left. Alternate flaps are off. The arm switch is off. The gear is down, showing down. Alternate nose and body gear are guards closed, no indications. This is also wired. And glide slope inhibit, no lights. Flap override, switches off, no indications. Gear override switches off, terrain override switches off, and no indication that the switch is pushed in. These are alternate action switches, so if one was on, it would look like that, and we don't want it in override, we want it off, switch off. Again, come down to CDU. Again, if I was the first officer, I'm the guy that already did, or guy or gal, already did the CDU pre-flight as far as I'm concerned, and I'll go back to the takeoff reference page to stay on that page. So I've already done the CDU pre-flight as DFO. So now we'll go down to our panel down here. Check that the off light, if you have an off light, check that the off light is extinguished. In this case, it's a switch. So if the radios were off, it would look like that. Nothing in the windows as far as frequency goes. We want to make sure the radio's on. And if you have the off light would be extinguished. We're in VHF left for this radio. That's the normal radio to use with the left radio tuning panel. And then frequencies as desired for now. We'd skip over the captain's audio panel, make sure data is displayed here. It's in center VHF. This is normally used for EICAS. And again, make sure the radio tuning panel is not off. Observer's audio panel will be as desired. If you have an observer, you could show them how to use this if they don't know how to use this. And the smoking sign's on and the seatbelt sign will come on at this time. Radar will be in weather turbulence. Both captain and FO will be in the auto mode, not the manual mode. We'll be in the left receiver for the radar. And don't necessarily have to do a test. Again, that's usually a maintenance function as well, depending on the airline. Center CDU brightness, we could bring that up. Rudder trim 0, aileron trim 0. The center trim is momentary action switch. You should be out. And then right radio tuning panels and right VHF, the radio is not off. And then we'll go to the audio panel. And again, I'd probably be in flight and speaker if I did my oxygen check. And I checked the oxygen mask microphone. I'd probably be like this at this point. And then I just want to go to right VHF, and I can stay on speaker if I'm going to use the speaker. And then I'm ready to call clearance delivery once I tune in the clearance frequency. While we're here, we could probably do that. Boeing clearance is 132.4. We'll just, again, tune it for today. We don't necessarily have to tune these in training. That would be clearance delivery. And then the EICAS would be, what is the EICAS? 12775. So we'll go 127 and 75. That'll be the EICAS. And then ground is going to be 121.9. So we'll tune that. Oops, wrong one. And then the tower is going to be 120.6. Yep. So again, I've got on the right radio tuning panel, I've got EICAS and clearance delivery. And then on the left, I have ground and tower. And then I'll put departure here on the center radio tuning panel. And that way it's I can reference it when I have to switch to a departure. I can look down here and then very easily then switch it. Let's see, I'm in right here, speaker, transponder, we'll go to 2000, indicating we don't have a clearance, and we'll be in standby here. Altitude reporting should be on, and the transponder could be in left or right, doesn't really matter. And then I'll adjust my seat, adjust my rudder pedals, and I'm done. Captain will come over and, again, lighting, we'd want to make sure it's up before I do anything. So I'll adjust my lighting for the outboard CRT, inboard CRT, and the panel lights. The background lights and the floodlights. And then I'll start from my EFIS control panel. And again, same things. I could check VOR, ADF here. I'll be in airport. I do not want terrain on. And TCAS off is displayed, that's fine. Flight path vector, I'm not going to use it. I want to be in baro here. And we want to be in inches, which we are. And we can set the altimeter to 2994, I think we said it was. VOR, again, if we check that, that's fine. And again, range would be as desired. I'm going to put it down at 10 miles because I know we're going to taxi here. Flight director on, auto throttle arm switch is in arm. We want to be in auto here, and the disengage bar is pushed up, flush with the bottom of the MCP. So you're really checking kind of those four things: flight director, auto throttle arm switch, bank angle limit selector in auto, and then that disengage bar's up. Come to your oxygen, check your foot and shoulder heaters, come up to the instrument source selectors, all 12 o'clock. Lighting we already did. We're going to go ahead and set the elapsed time, get rid of that. And then we want to set our GMT time. Now when you set it, you'll notice there's the clock has a run position, a hold position, some clocks they've changed this, a fast slow and a slow slew. In the run position, the clock will run. The hold position stops the clock, and then the fast slew will change the minutes, and the slow slew will change the hours. So if you bring it all the way down, you'll probably start to see the hours move. So I'm going to bring it in hold first. That stops the clock. And then I'll bring it all the way down. And you'll notice when I bring it all the way down, the hours start to move. That's kind of known as the, I think they call it SS. On the clock, I think it's labeled SS. Slow slew. I can't see it. So we're going to go to 17, I think it's 1752 for the GMT time. And when I get there, 17, I just move it up one. So now I went from slow slew to fast slew, and now it's changing the minutes. And the minutes are 50, what time is it? 53. So you notice I kind of have to wait till it gets all the way around. I can't speed this up. I just have to wait till it gets to 53. And then when it does, I'll just bring it back to run. And if you forget, it starts to go the other way. I mean, you'll have to go all the way around again. So here's 44, 45, 55, 45. So 50, 51, 52, 53, and now we'll go to run. Oops. Here we go. So now we're back to run, and that should keep the clock moving. Now 1753. If we wanted to now, let's see if that changed our GMT time. No, that's still showing 1914. This is coming from the GPS, and the GPS is not giving the correct time. For whatever reason. If the GPS was not working, it comes from the captain's clock. But right now, the time reference is coming from the GPS, and that's not showing a present time. Let's see if I can. Force it into. Let me try something here. Time. Yeah, here we go. Let's try this. I'm adjusting something on AeroWinks here. Yeah, there it goes. Now it did it. 1754. Okay, so I just copied the real world UTC to the simulated UTC, so that changed the clock. So again, the clock reference is coming from GPS, and if that's wrong, I can go into a setting here in AeroWinks, PSX, to copy the real world UTC into the sim, and that's what I had to do to get this back. Again, if GPS is not working, then the captain's clock would be referenced off of, or the time would be referenced off the captain's clock. And that's how it used to be. When we didn't have GPS, you would always set the time here at the captain's clock, and then it would change the time here. But with GPS now, it's just updated all the time, except in a sim like this. Okay, so let's see, where were we? We did that. Yeah, we're doing the clock, okay. So again, we can check the chrono, make sure it works. One push starts, one push stops, the other push resets. We're in run. The lapse time is 0. We're going to assume the date's checked. We won't go through how to change that or set that. RMI, VOR, VOR. And the PFD blank Toga Toga FD 8 degrees pitch up, wings level. 200 knots parked, or 200 knots is on the MCP, 30 knots parked for the airspeed, that's fine. Ground speed 0, that's what we expect to see. -8 on the radar altimeter, that's what we expect to see. And no flags. 200 north and 10,000 on the MCP because it's been powered up, and that's what these numbers go to on the mode control panel. They go to 200 north and 10,000. 2994 in the altimeter, field elevation is 20 feet, that all looks good. Normal, ground speed 0, same things here, no flags. TCAS off displayed. GPS IRS 3, that's good because the FMC position is coming off the GPS. And we have all 3 IRUs for the triple mix position. VOR, VOR, that's fine. Again, the main thing is no flags. We'll go to the ISFD. You can adjust the brightness there. The approach modes are not shown. That's good. 2994 on the altimeter here. Brake source light is illuminated. That's normal because you don't have an active brake source 4, 1, or 2. And you'll notice that we have 2200 psi. That's fine. And we could pump these up if we want to by bringing number 4 to aux, and that would pump this up to 3000, but this is fine to hold pressure. Auto brakes, again, because we have it here, I'm going to set it as the Captain RTO, and then I'm going to go to my CDU, and basically everything that the FO did I'm going to check. So I'll go to the ident page, model, engines, active nav database is current, position initialization. The last position is now the GPS position. That's good. UTC time is now correct. I'll go to the route page, Boeing field to Boeing field, Sonic 4.4, that's all good. And based on the flight plan, we're going to Orton, Vamps, Payne, all direct, and then Victor 23 to Seattle. And that matches what I have on my flight plan. And again, if I were to actually check the route with a real flight plan, I would have to go to the plan mode up here, and I could go to the legs page down here, and then I could step through the route, and while I'm doing that, I could check the courses and distances for each waypoint all the way through my route to make sure that what we put in agrees with what's on the flight plan as far as individual waypoints go. When we go from this point to this point to this point to this point to this point, then to page 2 and all the way through. But that's the main verification is right here. Courses and distances, not stepping through the route. Also, we check the progress page, and I don't think we mentioned this before. We check the progress page to make sure the total distance agrees with the distance on the flight plan. It could be off a little bit. That's normal because, depending on how you're going to come in and what it's referencing, you could have, 10, 20, 30 miles difference. That's fine. You don't want to see a huge difference. So we check this against the flight plan to make sure it's reasonable. We could also, at this point, well, let's go back here for a second. We'll go back to our route page. Let's see, we checked all that. And then the next step is to check our perf init page. So remember, we said you can't just go here now to 6 right. You got to push init ref. You'll get the index prompt here. Go to index, and then you can go to performance. 480 is the 0 fuel weight. Fuel on board 150,000. It's been using the APU a little bit, so fuel's been burning slightly. Gross weight 629.5, reserves 20, cost index 100. Cruise altitude is 1,000, step size is 2,000. Thrust limit page, TO2, climb 2, that's good. Takeoff reference page, flap 10, 1,000 foot acceleration height, 1,000 engine out, flap 5 thrust reduction. Nothing on the headwind and slope. It's a dry runway, and the V speeds are standing by. We look down here and see thrust limit, and nothing here other than dashes. Again, if you see pre-flight, it would mean the pre-flight's not complete. But if you see dashes and thrust limit, it means that the pre-flight is complete in terms of that all the boxes are filled out. Now you'll notice we don't have the CG yet, but it is a dashed entry. It's not a boxed entry. If it was boxes, that would be required to fill in. That's a required entry. In this case, trim is not necessarily a required entry because you could be getting it from other paperwork other than from the FMC. So even though that's not filled in yet, the pre-flight, as far as the CDU pre-flight is concerned, it's complete. All the boxes have been filled out, in other words. But it's not complete in terms of V speeds and the CG. Okay, so the captain checked all that. I'll stay on this page as well because we're going to want to put in our final numbers. And from there I come down to my thrust quadrant, and I can come across and check the trim, the speed brakes down. The forward thrust levers are idle, the reverse thrust levers are down, the flaps are up. Come around here and check the parking brake is set. Fuel control switches are cut off, stab trim guards closed, that's the auto position. These are spring-loaded to the neutral position. And then I can check my audio panel and make sure my audio panel is good. And again, if I want speaker, I could select speaker, and then I probably want to be on left. Again, I probably would have been flight here also if I checked my oxygen mask microphone, but then I'm going to want to go to left, VHF, in preparation for flight. And then from there I would adjust my seat, adjust my rudder pedals, and I'm pretty much done at that point. Notice I broke a rule here. So remember I said whenever you're in the plan mode, always go back to the map mode. And that's just kind of an unwritten rule here, because what can happen is you could leave it in plan and then you're not really oriented to the way you should be oriented, which is the way the airplane's pointing. So if we go back to the legs page, you'll notice I'm still on the center prompt here, the map center step, and so I want to go back to map. And now you'll see I'm back in the map mode. And now you'll see our heading is 332 and our track is 332. That's oriented to the way the airplane's pointing, not oriented to north. And that's how we want it. And we'll get the EICAS information. So we got 12775 tuned. And I don't know if you can hear that or not. I'll turn up the desktop audio a little bit.
This is Kilo, Bravo, Foxtrot, India, information Kilo. Weather report time 1750, runway in use 14, right, wind 110 at 12. Visibility greater than 10 kilometers. Temperature 10, dew point centigrade. Altimeter 200 minor, trend no sig, information Kilo, down. This is Kilo, Bravo, Foxtrot, India, information Kilo. Weather report time 1750, runway in use 14, right, wind 110 at 12. Visibility greater than 10 kilometers. Temperature 10, dew point centigrade. Altimeter 200 minor, trend no sig, information Kilo.
Okay, information Kilo is what we have. Or on our flight plan, we just said Bravo, in case we don't want to get the EICAS. And let me turn that desktop audio back down in case it's too loud when we start the engines. So we have the EICAS information. It's basically weather's good, sky clear, temperature is 10 Celsius, dew point 4, altimeter is 2994, 130 at 12 knots on the wind, and we're departing runway 14 right, and they said it's information Kilo. We'll go with Kilo today. So we then call for clearance. We could switch over here to clearance delivery, which would be 132.4, and again I'd make sure that I'm on right VHF. Speaker, if I'm using the headset, I don't have to have speaker on, but I'm probably going to have speaker on at this point, maybe not use the headset. And 132.4 is clearance delivery, and then I could hit my push to talk switch on the control column, the RT switch, or I could come down here and push this switch and broadcast. So we'll go through that and we'll say we call Boeing Field Clearance Delivery. It's a Sonic 44 Heavy IFR, local IFR with information kilo. And he says Sonic 44 Heavy, you're cleared to the Boeing field via local IFR, departing 14 right via the Kent 8 departure. After Zigged, direct Vamps. Climb and maintain 6,000. Expect 1,000 5 minutes after departure. Seattle departure will be 126.5 and squawk 7474. And then I repeat 7474 Sonic 44 Heavy. And he might say, give ground a call when you're ready for starting engines. And I'd say 44 Heavy, roger. Okay, so we have our clearance, and the departure is 26.5. So we'll put that in here. Here. By the way, I'm not going to do this every time with the radios. We're just doing it today. And eventually we'll get to the point where we don't use the radios. But we're just kind of going through this just to show how to use the radios. So 26.5 is departure. That's there as a reference. Again, this is ground, this is tower, and then we have 26.5 departure, and the squawk is 7474, so we'll put that in. This is the digital. You may have the analog where you actually have to rotate the rotary selectors to get 7474. So it just depends what type transponder panel you have. This is the more new transponder panel where it's digital. And again, are we going to set anything in the MCP? Not yet. And that's the hardest thing for guys to learn with Boeing procedures, is that we don't reach up here and select our heading and altitude. And that's what guys want to do right now when they get the clearance. So they want to come up here and spin things. And there's nothing wrong with that. It's just that it's not the Boeing procedure. The Boeing procedure is to wait for the final numbers, and then once you get your final numbers, then you can set the MCP. So we're going to say we have the EICAS, we have the clearance, we have our final paperwork, we have our final numbers. The zero fuel weight we'll say is 480. It hasn't changed. It's unchanged. And we'll just go check it to make sure. 480, no change in the zero fuel weight, and the CG we'll say is 25. So we'll go to the takeoff page, put in 25%, and now it can figure based on the weight that we have what the trim setting will be, 5.0, and then our V speeds now can be activated. And once our final paperwork is complete, we can go ahead and then set the MCP. So we'll come up here and we'll set V2, which is going to be 158. Yikes. Yikes. There we are, 158. And the heading is going to be runway heading, which is going to be 135. Is runway heading off the airport diagram, the 10-9 page. And our initial altitude, he gave us 6,000, so that's going to bypass that 2,000 is zigged. He gave us a climb and maintain 6,000, so we're going to put in 6,000. We don't have to obey the altitude is zigged. And then we want to put in the SID departure because we don't have it. So we're going to go departure arrival. Select runway 14 right again. It's just going to bring up the SIDs for runway 14 right. And the only two SIDs you have for 14 right is Kent 8 and Nervna 1. So we want the Kent 8. There is no transition. We'll go ahead and execute that. And then we'll go to the legs page and check it. You'll see we have a 135 heading to intercept the 135 to Zigged at 2,000 feet. He gave us 6,000, so we're cleared unrestricted up to 6,000. We'll delete that 2,000 foot restriction. And then after Zigged, He said expect, he said direct vamps. He didn't say expect. He said after Zigid, direct vamps. So we'll bring vamps to the scratch pad, lines selected into the boxes, and that's going to bypass Orton basically. And we'll execute that. No restrictions here, so we'll climb to 6,000. We're going to come out here to Zigid, and then we're going to go to vamps, and that makes it a little more of a... So again, if we wanted to look at it, we could go to plan. We could bring our range up. And not that much. And now you can see what we're doing here. We're coming off a 1-4 right to Zigid. And then after Zigid, instead, Orton was way over here. And after Zigid, it's going to be direct to vamps and then to pane. So it kind of does a little round robin here, which makes more sense. I don't want to come here to Orton and have to make a, a sharp turn back to vamps. So normally ATC would not have you do something like that. So we'll go back to map. Again, if we're done with plan, we don't have to step through it in this case. And so we got our 158 V2. We're going to arm VNAV. We're going to arm LNAV because we're going to fly the Ken 8. And our initial heading is 135, and our initial heading is 6,000 feet. Oh, this thing's driving me nuts. As far as every time my mouse is in a different position today, and it keeps bumping something. But the control column's in the way, so I have to have it over here. And not ideal. Okay, so we set the MCP. Next thing we do is a crew briefing. Oh, and you can see it. And see, going back now, I can see I didn't do something here. I forgot something here. Let me go back. I didn't cancel these messages. So when I was here for the FO, and I came down here and checked here to here to here, and I got to the train override, I should have come here to the EICAS. I missed this. So I want to check these indications are all good. All good. Nothing's missing. I'm looking for missing information. And while I'm here, I'll just check the oil quantity again, make sure it's good. I also want to check the status page again just to make sure it's good. Make sure there's no status messages. Blank. That's what I want to see. I could check here again just to make sure everything's good again, just quickly. But the main thing I want to do here is check that there's no missing data, because if there is, there might be an EIU problem. And I also want to check the messages and make sure that they're normal. I got shutdown messages, brake source, fuel pumps are on, go to the next page, cancel. Fuel pumps, yeah, that's all good. Cancel, nothing else. These are all normal messages. So as a result, I can then cancel them like I did. So I checked them, check. Next page, check. Cancel, blank. I want to leave that blank. And then I would have gone to my CDU, so I missed this right here. So now we would do, we could check the doors, see how they're doing down there. They're all closed up down there. Since I got my EICAS, I got my clearance, I've got my final numbers, I set the MCP, now I could do a crew briefing. Again, we're going to forego that today. We'll just say standard briefing. We're going to the local area to do air work, and we'll say standard briefing. Keep an eye on me, I'll keep an eye on you. Any questions? No questions. Okay, we'll brief more when we start going from point A to point B. We'll do a crew briefing. And if that's all complete, then if we probably, once we completed the check, here's another thing I didn't do. And sometimes that happens, then you can go to the pre-flight checklist after, but usually we do the pre-flight checklist after you get to the point where you both complete your setup. So he completed his, adjusted his seat, adjusted his rudder pedals. I did my setup. I adjusted my seat, adjusted my rudder pedals, and now I would call for the pre-flight checklist. Now I noticed I forgot it, but I know I didn't do it, so I'm calling for the pre-flight checklist now. So it's a little late, again, but talking, I forgot about it too. So let's do the pre-flight checklist.
Pre-flight checklist.
Now, hopefully you can hear this. I'm going to turn up the sound a little bit. There we go.
Oxygen.
Tested 100%.
Flight instruments.
Heading 332, altimeter 299 or 4 inches.
Parking brake.
Set.
Fuel control switches.
Cutoff.
Pre-flight checklist completed.
Thank you. And we'll go ahead and we'll say flight deck to ground. We'll say go ahead. We'll say you can go ahead and remove ground power at this time. And then we'll go ahead and remove ground power. And he'll say, Roger, we'll disconnect ground power. And again, we'll make sure that APU is on before we remove ground power. And now we're ready for the doors are closed, final paperwork's in, we're ready for the before start procedure and the before start checklist. So we'd call ground and get a clearance to start. So we'll say Boeing field ground, Sonic 44 Heavy, we'd like to start engines at Bravo 4. And he'd say Sonic 44 Heavy, clear to start engines, give me a call when you're ready to taxi. Roger, will do. And I'd say flight deck to ground, and he'd say go ahead, and I'd say we'd like to pressurize hydraulics at this time. And he'd say you're cleared to pressurize hydraulics. And I'd say cleared to pressurize, thank you. And then I'd say before start procedure. And that would launch the FO into the before start procedure. So the before start procedure we said is to bring, make sure APU 2 is on, which it is. Again, it might not be if you didn't switch over. So we want to make sure that's on. Bring number 4 to aux. Number 1 to aux. Number 2 and 3 to auto. Turn on all the fuel pumps containing usable fuel. I know there's nothing in the center, so I'm going to turn on all fuel pumps. Make sure the cross feeds are open. I'm going to turn the beacon to both. And then I'll come down here and push recall as the FO. Oh, that drives me nuts. And engine 1, 2, 3, 4 shutdown. And he would say check, and then I'd cancel. You might even have a TCAS off message here. It depends on whether, sometimes if you're in PMDG, you'll see a TCAS off message here as well. That's normal until you get the TCAS on. In our case, we don't have it on the Aerowinks model, but if you did, that would be a normal message. And then cancel. Captain, meanwhile, he's going to set his trim to 5 units. I'll go ahead and do that. Sets 5 units, and he'll check 0 and 0. And then we'll call for the before start checklist.
Before start checklist. Flight deck door.
Not required.
Passenger signs.
On.
MCP.
V2 158, heading 135, altitude 6,000.
Takeoff speeds.
V1 127, VR 143, V2 158. And again, that would be something he would repeat, but Mr. Sylvan doesn't know to repeat that. I'll go to legs here. Now that he's done.
CDU pre-flight.
Completed.
Trim.
5.0 units, 0 and 0.
Taxi and takeoff briefing.
Completed.
Beacon.
Both.
Before start checklist completed.
Thank you. So again, I'll make sure now that I'm in takeoff reference page and legs page. Takeoff reference for the pilot flying, who in this case is going to be me, the captain, and the legs page for the pilot monitoring. And then we could call ground, and we have clearance for engine start. So flight deck to ground, we'd like to start all engines at this time, sequence 4, 3, 2, 1. And I'll say clear to start all engines. I'll say clear to start all engines, thank you. And I'll say start 4 and 3. And the FO will come down and turn the packs off if he hasn't already. 2 packs off, or 3. And then he'll bring 4 and 3 start switches out. And then the captain will bring 4 and 3 fuel control switches to run. And we've got rotation. And we've got oil pressure. And we've got N1. And we've got fuel flow. And we've got light off. And again, I don't have to call those out, but that's what I'm looking for. Okay, we've got a hydraulic pressure demand 4. We know what that is. Go ahead and cancel it. Cancels it. And flight deck to ground 4 and 3 are stable, starting 1 and 2. And you'd say you're clear on 1 and 2. And I'd say start 1 and 2. And now the FO would reach up and you could start 1 and 2 or 2 and 1. They'd probably say 2 and 1. First officer pulls these out, start switches. Captain goes to run. That's when you get the light illuminated in the switch. Your hand comes off the fuel control switches and it rests on your knee during an auto start. Again, we have rotation, we have oil pressure, we have N1, we have fuel flow, we have light off. Okay, we know what hydraulic pressure demand 1 is. Cancel that. And then I would say flight deck to ground. We have 4 good starts. You're clear disconnect. Show me the pin on the left side, and we'll see you next time. And he says, okay, clear disconnect. Pin removed. Wave off will be on the left. Have a good flight. See you next time. Bye-bye. And he leaves. And then I would say before taxi procedure. And then the FO is going to go start with the APU. It's going to turn that off. It's going to bring a demand pump 1 to auto, demand pump 4 to auto. Nacelle anti-ice if we need it. We don't need it today. It's 10 degrees Celsius. There's no visible moisture. And we'll bring the aft cargo heat on. And we'll bring packs 2 and 3 on. And we'll go to flaps 10. Oops, too far there. The FO will also select the status page here for the flight control check. And then he'd come down and go to flaps to 10. And then he'd bring the transponder to transponder. Okay, so that's the flow pattern. And once the flaps are 10, we'd say, captain would say flight control check. And that'll alert the FO to look, at the flight controls and check the flight controls with him as he does it. So we'll go to the right, 3 up, 2 down, neutral. Now we'll go to the left, 3 up, 2 down, neutral. And again, I'm checking for full and correct movement and that it's moving the proper direction. So you're checking 2 things, full deflection and it's moving the right way. Elevator 2 down, checks. Neutral, elevator 2 up, checks, neutral, and then I'll hold the tiller. And while I'm holding the tiller, I'll do the rudder. The rudder 2 left, neutral, rudder 2 right, neutral. And again, I'm holding the tiller so that the nose wheel doesn't move when I do that rudder check. And then if that's complete, then we'll go ahead and blank the status. We want this blank for takeoff, and then we'll push recall. The FO would push recall. Should see nothing there. And then we could call for the before taxi checklist. So before taxi checklist.
Before taxi checklist. Anti-ice.
Auto.
Recall.
checked.
Auto brake.
RTO,
Flight controls.
checked.
Ground equipment.
Clear.
Before taxi checklist completed.
Okay, and normally we say clear left, clear right if you had a crew. And again, you can see that I'm checking the auto brakes, right here. This is where I'm looking for the RTO. Yeah, you can look here as well, but I'm really looking to see that I have the memo message. Okay, then I would tell the FO taxi clearance, and he would go to ground, and I'll say taxi light on. I'll turn that on. And then he's going to go ahead and contact the ground. Boeing Field Ground, Sonic 44 Heavy, taxi from Bravo 4. It'll say Sonic 44 Heavy, taxi via the Boeing ramp to holding point Bravo 1. Holding point Bravo 1 for Sonic 44 Heavy. And I'll go ahead and release the parking brake.
Before takeoff checklist.
Oh, sorry, wrong button. Not yet, so Mr. Sylvan, not yet, First Officer Sylvan. I'll release the parking brake. Now I'll release it. That should be the proper button. So I'll see the parking brake message goes out, memo message, and then I can start the taxi. So just add a little bit of power. Again, usually no more than 40%. If you're lighter, it's going to start moving way before 40%, but usually no more than 40 to 45% is fine for taxiing or starting the taxi. Then when you start to move, then you want to kind of back off on the thrust levers to idle and manage your thrust so that you're not riding the brakes. Okay, so now we would say no changes to the briefing. We're going Ken 8 departure 6,000, expecting 1,000 5 minutes after. The squawk is in the box and departure is 26.5. And I'm going to be in terrain and you be in weather. So I'll select terrain and he would select weather. And then I would say before takeoff checklist, and we'll slow our speed down here and we'll start to turn. Stop the airplane right here, and we'll call we'll do the before takeoff checklist.
Flaps.
10.
Before takeoff checklist completed.
Thank you. And now we'll switch to the tower, and we'll call the tower Boeing Field, or Boeing Tower. Sonic 44 Heavy, ready for departure, runway 14 right. And he would say, Sonic 44 Heavy, line up and wait, runway 14 right. Line up and wait, 14 right, Sonic 44 Heavy. And now we can do our final items, which are going to be to turn the lights on, except the inboards. We can turn our strobes on, we can turn our wing on, we can turn anything we want on. Transponder will go to RATA. And then I will again release the brake if I had it on. Add a little bit of power and start to move. And then I'll line up 14 right. Up 14 right. And now we'll go ahead and I'm going to turn on the inboard landing lights now. We'll say we're clear for takeoff, just so I don't have to come back here and do it. And again, we would verify the markings. We'd verify the entry of 14 right. We'd see the runway markings, the signage. We check the runway indication that it says 14 right. We check our ND to make sure that it says 14 right as well. Everything agrees. The heading agrees, and All the runway markings agree, and very important to check that before we take the runway. We'd also check the approach corridor to make sure it's clear before we take the runway. Okay, now I'm going to change my layout again. Stand by. Load setting, let's see, I'm going to change it to that. And again, if we were in a lower range, we could now adjust our range again to a higher range. And usually it's one where you can see the active waypoint. The active waypoint right now is a conditional waypoint. It's to fly a heading until we intercept the course to Zigid. So right now you'll notice that there's nothing here because it's a conditional waypoint. But once that conditional waypoint is met, then it will change to Zigid, and Zigid will go magenta. But right now there is no active waypoint, but I still want a range where I can see stuff. I don't want a low range where I can't really see anything. So you can see here I can see Seattle, I'm going to Zigid, I can see stuff in this configuration. Okay, so we're ready for takeoff. Here's where we're gonna start the lesson finally. So in the future, we'll modify the cockpit setup. We'll probably still do a full cockpit setup on lesson 3, but it's even going to go faster. And then as we go, we'll probably start with a live airplane. We're not going to do the electrical power up. We'll start with an airplane that's powered with external power, and then we'll configure from there. So the electrical power up procedure won't be done on lesson 3. And then as we continue to go, we'll get to the point where we'll do a lot of the flight deck preparation ahead of time. I'm not going to go through the whole thing, but we'll get to the point where we're maybe down to starting engines, and then because maybe we're going to do some non-normal engine starts or something like that. So as we get going here, we'll bypass the flight deck preparation, but for the first 2 or 3 lessons, we'll do it. Okay, the first takeoff we're going to make is going to be a flight director off takeoff. So we'll bring the flight directors off. And what we're going to do is we're going to set 70% N1. And that'll be just below, right here, just below, since we're GE engines, it'll be kind of just below the N1 indications, like right here. It's kind of like making an underline under the N1. Not right under it, but just slightly below it. That'll be 70%. We'll stabilize momentarily. We'll push toga. Power will come up. I'll say set takeoff thrust. And you're going to hear Mr. Sylvan say takeoff thrust set. As we roll down the runway, I'll keep directional control with nose wheel steering, and then 40 to 60 knots, eventually rudder will be effective, and I'll keep directional control with rudder. Mr. Sylvan, First Officer Sylvan, is going to call 80 knots, so I'll say check. And then he'll call out V1. And he'll call out rotate. I think that's what he says, rotate. And then I'll rotate about 2 to 2.5 degrees per second. And I'll continue the rate. It's a smooth, continuous rate of rotation right up to your pitch. Now today we're mid-range weight. I have no flight directors, so I'm going to pitch for about 18 to 20 degrees. With a positive rate, we'll get the gear up. And then we'll climb out at 18 to 20 degrees of pitch. At the same time, keep looking at my airspeed to make sure it's not falling off or increasing. And then when we get to 1,000 feet, I'm going to lower the nose to 10 degrees, accelerate for flap retraction. And then when I get to flaps 5, I'll say flaps 5, thrust. And what that's going to do is by pushing the thrust button, it'll go from TO2 to climb 2. And then I'll go flaps 1 at the flaps 1 speed, and then I'll say set speed 250. And I'm going to have to come up here with my mouse and go to 250, and also push the thrust button when I did that before. So it's kind of like I have to do two things, hand fly and do that, but we'll see if it works. Then I'll say set speed 250, and then we'll go flaps up. And once the flaps are up and we're accelerating, I'll say auto throttle speed mode, and then the auto throttle will go into the speed mode. So this is a raw data takeoff. It's not a normal takeoff. It's just a demonstration takeoff. It's a demonstration to show pitch attitude on takeoff, rotation rate, and things like that. So parking brake is released. We're clear for takeoff. The inboard landing lights would come on, and let's do that first takeoff. So I'm going to set 70% on one. That'll be right about here, roughly. Momentarily stabilize, push toga, set takeoff thrust.
Thrust set. $80 knots.
Check.
V1.
Okay, my hands come off the thrust levers of V1, and I'll start to rotate slightly before
Rotate.
V1 or VR. So it's just a smooth, continuous rate of rotation up to about 18 degrees, 18, 20 degrees. Just positive rate, gear up.
Positive rate. Gear up.
And now I'll just kind of look at my speed. If it's, is it decreasing, increasing, what's it doing? It's kind of staying the same. Decreasing a little bit, so I'll lower the nose. 1,000 feet's coming up. 1,000 feet, I'm going to lower the nose for acceleration. And I'm going to trim. I'll trim for that about 10 degrees of pitch. And we'll accelerate. Right about in here when it shows flaps 5, I'll go flaps 5.
Flaps 5.
And I'll say thrust. And so I push the thrust button, and that'll change me from takeoff thrust, TO2 to climb 2. And now I'll go flaps 1.
Flaps 1.
At this point I'll say set speed 250. And I'll make it 253. I'll lower the nose. Took my hand off the control column there to get the MCP. Go flaps up.
Flaps up.
And again, once I get on speed, then I can lift the nose up a little bit and kind of stay at 253 knots. If it starts to drop, I can lower the nose. If it starts to increase, but yeah, around 10 to 12 degrees is probably going to be pretty good to climb right here. And then I'll go auto throttle speed mode. That's what I didn't do. So you can see the speed started to run away, started to go above 250, so then I went to the speed mode. Should have done it earlier. I was talking, yakking. So now I'll just adjust that pitch. And once I get to 5,000 feet, I'll go ahead and lower the nose to about 1,000 feet a minute. So right about in here, I can lower the nose to get about 1,000 feet a minute. Because I don't want to go screaming up there at 2,000 feet a minute. And then I would level off at 6,000. So I'm going to go ahead and I took my hand off the control column. I'm going to go back to the, let's see, back to situation. Let's load. So I'm going to go back to takeoff practice. Okay, I'm going to reset us on the ground. Back on the ground. Next takeoff we're going to do is going to be a flight director takeoff, but this time we're going to not use LNAV and not use VNAV. So this gets a little more close to a normal takeoff. This would be a takeoff. We were going to fly runway heading for radar vectors for a Zigid, let's say. And we're going to, and VNAV's not working. So we have to use flight level change. So now the flight directors are on. We got blank toga toga, but we have no VNAV armed, no LNAV armed. And now we're going to do the same thing. So let me know, is the background noise too noisy? I can turn that down. Can you hear Sylvan okay? Or should I turn down the background noise? To me, it's a little loud. Anybody have any input on that or not? Okay, you let me know if you can hear me okay and the background noise is not too noisy, then I'll continue with where it is. And hopefully you can hear First Officer Sylvan make the calls. Okay, so next takeoff. We're going to go to 70% N1, stabilize, push toga, roll down the runway. Same things, 80 knots, check. V1, rotate, positive rate, gear up. 400 feet, we're going to go to heading select. That's where we would go to heading select, and that'll fly runway heading of 135. At 1,000 feet, we want to accelerate for flap retraction. So at that point, we're going to go flight level change, speed 253. I think that's what the speed is on the VNAV page. You know, I could use 250, that's close enough, but we'll go to 253. I think it's actually 253 on the climb page. And then we'll retract flaps. Flaps 5. And at that point, we're going to go flaps 5 thrust. Again, because VNAV is not armed. VNAV is the automatic stuff that does automatic stuff for us. So as a result, if I use flight level change, I have to manually get the thrust out of takeoff into climb. So in order to do that, I have to push the thrust button again. And then I'll go flaps 1, flaps up, and then we'll accelerate to our up speed, which is 253 or a little more than that. And then we'll, well, no, it will be 253. And it's the up bug plus about 20. And then we'll be in a pitch mode, so automatically that'll capture once we get to 6,000 feet, that's going to capture automatically. And this time I'll get the autopilot on, you know, it's around 300-400 feet, and we'll watch things happen. Okay, so here we go. We're going to set 70% N1. Stabilize, push toga, set takeoff thrust.
Thrust set. $80 knots.
Check.
V1. Rotate.
Again, nice smooth rotation. Positive rate, gear up.
Positive rate, gear up.
Uh, 250 feet we can get on the autopilot, so we'll do that now. 400 feet we'll go heading select. Notice the green attention box around there for 10 seconds. At 1,000 feet, we're going to go flight level change, and we're going to go speed 253. And now the flight directors will pitch down, the autopilot will pitch down to accelerate us for flap retraction. We're at the flap 5 speed and increasing, so we're going to go flaps 5.
Flaps 5.
And we'll go thrust because we have to get out of TO2 and go to climb 2. And so by doing that, by selecting thrust, it goes to climb 2. And we're at flaps 1 bug and increasing, so we'll say flaps 1.
Flaps 1.
And notice the enunciations on my FMA are thrust, heading select, flight level change speed. Heading select for roll, thrust for pitch, thrust for auto throttle, and flight level change speed for pitch. There's the up bug and increasing. We want to see that arrow going up. And we'll go flaps up.
Flaps up.
And once the airplane gets on speed, the nose will pitch up in order to hold that speed, and the airplane will climb to 6,000. When it gets close to 6,000, it will automatically capture the altitude that's in the MCP window, which right now is 6,000 feet. And then we'll go from thrust flight level change speed to speed alt, or altitude hold. I gotta turn off this TCAS. This will drive me nuts.
Traffic.
And
Traffic.
I'm gonna turn that off in a minute here. That'll drive me nuts because we'll be getting TCAS alerts. So I turn the traffic off. Okay, so there's 1,000 level off.
1,000 feet level off.
Horn and the white box come up anytime you are within 900 feet of the selected altitude. And then they go out 300 feet. So when we get right here at around 300 feet, they go back to the normal white box. There's different options for that, but usually it's 900 feet and 300 before. 900 feet, you get the horn. And or if you have the horn, that's an option. And you get a heavy white box around here and around here. And then at 300 feet before, some airlines is 200 feet, depends on the option. It'll go back to normal. This will be a normal white box. This box will go away, that white box, and the airplane levels off. Notice it went into speed and alt. And once it does that, we're out of flight level change. Notice that flight level change light bar. Oh, this drives me nuts. That flight level change light bar is extinguished. And we have speed and altitude hold. But these both happened automatically as a function of capturing the altitude. Okay, so let's go back on the ground. Let's see, takeoff. Let's go back on the ground. Oh, thanks, Walter. Okay, it's okay. Because I'm worried the background sound is a little too much, and then you may not be able to hear me clearly, but I think you're okay. If not, just let me know. Okay, third takeoff. This one's going to be more normal now because we have the Kent 8 departure. Let's just make sure that's still in here. We don't have the 2,000 foot restriction because we don't want it. And looks like it's still in okay, no problem. And we're climbing to 6,000 feet. And this time we're going to use LNAV and VNAV. So what's going to happen is, again, I'll set 70% N1, stabilize, push toga, set takeoff thrust. Mr. Silva's going to say thrust set. 80 knots check, I'll say. He'll say V1, rotate, and then I'll rotate again 2 to 2.5 degrees per second. With the positive rate, we'll get the gear up. At 50 feet RA, LNAV will engage. Again, assuming you have an active flight plan, assuming that you're above 50 feet, and assuming you have LNAV armed, and LNAV will engage at 50 feet. VNAV will engage at 400 feet. And again, that's assuming you have VNAV armed and the performance initialization page is complete. It has to have that information in order for VNAV to engage. Now VNAV engages, like we said in the briefing, at 400 feet, but it doesn't do anything till 1,000 feet because that's what we have programmed. Remember, we have programmed in the takeoff reference page, which I want to be on. We have programmed 1,000 feet and flap 5 thrust reduction, which is NADP2. And in this case, at 1,000 feet is where VNAV is going to do something, and that's accelerate us for flap retraction. And we'll retract flaps on schedule. When we go flaps 5, the thrust is automatically going to change to TO2. We don't have to push the thrust button now. And we'll retract flaps on schedule. And then, again, you'll notice everything's pretty much automatic here, and I'm not doing much other than flying the airplane, getting the autopilot on, and then letting LNAV and VNAV do its job. Again, notice the active waypoint. There is no active waypoint. It's going to fly a 135 course. Again, if you go to legs page, it's going to fly a 135 heading to intercept the 135 at Zigged. And so eventually Zigged will become the active waypoint. But initially it's a conditional waypoint, which means that it's not a fixed geographic point. This can vary depending on when the condition is satisfied. When the condition is satisfied, then it'll move to the next waypoint. Okay, so let me put this how I want it. Okay, third takeoff. Okay, we'll set 70% N1. Stabilize, push toga. Set takeoff thrust.
Thrust set. $80 knots.
Check. Now again, at V1, I'll take my hands off the thrust levers. That's the takeoff decision point, so that's the point where you want to take your hands off the thrust levers right here.
V1.
And then I'll start the rotation a little before V1.
Rotate.
Positive rate, gear up.
Positive rate. Gear up.
Okay, we'll get the left autopilot command. Now notice LNAV engaged at 50 feet. VNAV is now engaging at 400 feet. LNAV is now flying that conditional waypoint. That's what it's doing. 1,000 feet, now the airplane's going to accelerate for flap retraction. When we go to flaps 5, you'll notice that TO2 will change to climb 2. So there's flaps 5 with the arrow increasing. Go flaps 5, and notice the thrust changes from TO2 to climb 2 automatically. Once I'm airborne, if we don't have the auto VNAV page, I'll go to VNAV. It's normal once you're airborne to go to VNAV. Some airplanes have an automatic feature where it'll automatically select the VNAV climb page.
Flaps 1.
We'll go flaps 1. And we're at the up bug and the arrow's increasing, so we can go flaps up, as long as we're accelerating.
Flaps up.
Notice again, the active waypoint is still that conditional waypoint. It hasn't changed yet. Zigged is white, so it's not the active waypoint. And here comes that pesky traffic again. Let me turn that off. Okay, we'll turn that off. So you notice once we get on speed, the nose pitched up, and now we've got a pretty good climb rate going. That climb 2 is pretty low for this weight, because you can see it had a little trouble accelerating. Now we're in a VNAV climb, thrust ref, VNAV speed, LNAV for the roll mode. As soon as it captures the altitude, automatically it's going to go into VNAV alt, and the auto throttle will go into the speed mode. It's still in altitude hold mode, but we're in VNAV, so it'll say VNAV alt.
1,000 feet load off.
And we have the MCP set at 6,000. So it's going to go from VNAV speed to VNAV alt, and you see it right here, VNAV alt speed. And the airplane will level off at 6,000. The auto throttle will retard to maintain the speed, and that's an intermediate level off via the mode control panel. Not a constraint altitude, it's a MCP altitude intermediate level off, so it'll go to VNAV alt. Now you see here we're approaching Ziggurat, and now it just changed. You see that conditional waypoint just went out. Zig is the active waypoint, but not for long. This is going to go white, Ziggurat, and then VAMPS will go magenta. And again, we always want to keep our heading bug in front of us, so we'll spin the heading bug to course. Let's climb to 1,000. We'll go to 1,000. So we'll go to 11,000, which is our cruise altitude. We're in a VNAV. Sorry, we're in a VNAV level off. 6,000 feet. So to get the airplane to climb again, we have to push the altitude selector, and that will allow us to continue the climb in VNAV. And so if I push the altitude selector, it'll change to thrust ref VNAV speed. The auto throttle is going to go right to the reference thrust, which is 86.3% climb 2. And you'll notice these little lines are magenta now instead of green when you're in VNAV. Now the speed right now on the VNAV climb page down here is 253 below 10,000. But once we pass 10,000, then it's going to accelerate to 328 knots, or 0.60 Mach. And our cruise altitude is 1,000. Again, I can't see anything here, and I know pain's the active waypoint, so I want to increase my range. So what I'll do here is just bring the range up a little bit so I can see the active waypoint, and there it is. I always want to be in a range where I can see the active waypoint. So again, the elevator is pitching for the speed. The speed is being controlled by the computer, and the window is blank because the computer, the FMC, is controlling the speed. The auto throttle is going right up to the reference thrust. The reference thrust is 87.1, that's where it is. Passing 10,000 feet, you'll notice this speed is going to drop out. It's going to go blank.
1,000 feet load off.
And the econ speed is now active. And so the speed bug goes up to 327, and the airplane's going to accelerate up to 327 knots. Now I don't want to go that fast in the practice area here, so what I'm going to do is speed intervene, open the window. I've taken control away from the FMC, and I'm controlling the speed directly now. And that's why down here it says active MCP speed climb, because I'm controlling the speed through the mode control panel. So now what I'll do is lower the speed to 290. And I'm probably going to bring it back to 250. You'll notice now we're in VNAV path, and we're in VNAV path because we're at the programmed cruise altitude. And so the programmed cruise altitude is 11,000 feet. That's where we are. So the pitch enunciation will go into VNAV path and not VNAV L. And again, I want my heading bug to course. I'm busy talking, but eventually I'll see it. The heading bug is not to course, so I'll put it to course. I want it always in front of me. So when I made that turn from Vamps to Payne, I would have spun that heading bug in front of me. Okay, so now we're going to talk about the roll modes. The roll modes are heading select, heading hold, and LNAV. Right now we're in LNAV. We're following the programmed route from our present position, which is the tip of the triangle, to Payne VOR. And of course, if we let it, it'll fly all of our programmed route in LNAV if ATC allows us, and that's the clearance to do so. But what we're going to do now is we're going to come out of LNAV and go to heading select. Now heading select will basically, we get a green attention box for 10 seconds, and heading select is going to fly the heading that's in the window, in this case 325. Now you'll notice we got a slight quartering tailwind here. So our heading is the upside down triangle, and that's going to be 325, and that's where it is, 325. And see, the heading bug is at 325, but the track is actually 327 because of this quartering tailwind. So you've got the heading, which is different from the track because of this wind. If we turn heading select now, it's going to turn in the direction that we spin the knob. So right now, if we want to make a right turn and we spin the knob to the right, the airplane's going to make a right turn. So let's go to a heading of, let's spin around quite a ways. Let's go to 080. And now you notice the airplane is in heading select already, so it's going to turn whichever way we spin the selector. Now notice as we come up with a tailwind, watch that tailwind, the heading and the track will be the same. You see that? They're exactly the same right now. But as we continue the turn, this is going to become more of a crosswind, and then the heading and the track are going to diverge. Notice how they're diverging from each other now because of this crosswind. We're going to be crabbed into the wind to fly this track. I think you're all familiar with the symbology on the PFD, but anything in magenta is what's on the mode control panel. So right now 250, heading 080 and 11,000, that's what we have up here. 250, 080, 11,000, that's in magenta. Notice on the compass rose here, the track is represented by the white dashed line, and the heading is the upside down triangle. This down here is a heading up display, because heading is displayed at the top. This is a track up display, because track is displayed at the top. You'll notice the tip of the triangle, and you take that white line and extend it up. That's our track. But our heading is actually 080 because we got this crosswind from the right blowing to the left, 182 at 26 knots. So because of that, the airplane is crabbed into the wind in order to fly that heading, but the actual track of the airplane is 075 with that wind. Let's continue the right turn now to a heading of, let's spin it all the way around. If we do this, the airplane will turn all the way around to this heading. As long as they don't cross that track line, the airplane's going to do a 180-degree turn. 180-degree turn. So if I left this like this, it'll go ahead and continue the turn right around to this 091 heading. So it will make a 180-degree turn, or 360 if you let it. Now, as soon as I cross that track line, it says, oh, no, now all bets are off. I'm going to roll wings level, because you're telling it now to turn the shortest direction to that heading. So as long as you don't cross that track line, it'll turn. But as soon as you cross that track line, it's going to say, well, you want to fly that heading, I'm going to roll out. So again, the airplane will turn more than 180 degrees up to almost 360 as long as it doesn't cross the track line. Let's turn right now to a heading of 210. You'll notice the bank angle limit selector is in auto, and so it's going to pick the bank angle, and right now the bank angle is 21 degrees, 22 degrees. It's basing it on the speed. So as long as you have a slower speed, it can go up to 25 degrees. If you have a faster speed, it would tend to stay at 15 degrees. Let's turn the heading bug around again. Again, notice the airplane starts to make a turn. You've got these little noodles down here, which are called trend vectors. And each one of these is 30, 60, and 90 seconds. That's where the first one is where you're going to be in 30 seconds. The second one is where you're going to be in 60 seconds. And the third one is where you're going to be in 90 seconds. If you decrease the range, then you're only going to get two of these noodles, trend vectors. This is where you're going to be in 30 seconds. This is where you're going to be in 60 seconds right here. If you go down another range, down to 10 miles, you notice we only have one trend vector. Now this is where you're going to be in 30 seconds. So if you're in the 40-mile range or greater, you're going to have all three trend vectors. Okay, let's turn the heading bug again. This time when we get to a heading of 330, we're going to push heading hold. And when you push heading hold, you're telling the airplane, go ahead and hold this heading. But it can't hold this specific heading. So here we go, 330. Well, I didn't push it quite at 330. Now the airplane's simply going to roll wings level and then hold that heading. Now you'll notice if you're in heading hold and you push heading select, it's going to turn the shortest direction to where the magenta bug is. And right now that'll be a right turn. That's the shortest direction. So it's not going to turn left, it's going to turn right because it knows to go the shortest direction to get to that heading, 060. So let's push heading select. And now the airplane will turn right, comes out of heading hold, goes into heading select, green attention box for 30 seconds, and the airplane starts to turn. Now, I'm going to push this at north again. Let's try to get a little more accurate here. There's north, so I'll push heading hold. And now again, like we said, it'll roll wings level and then hold that heading. It won't go back to north. So you'll notice if you wanted to go back to north, you'd have to reset the heading bug to north and then go back to north. You'd have to reset the heading bug and go heading select. And now it would turn back to north. Shortest direction, which is a left turn. Again, the bank angle limit selector only works in heading select. If you take it out of auto and put it into 5, 10, 15, 20, or 25, it's going to hold the bank angle that you set. So in this case, if I were to make another, let's make a right turn. If I were to make a right turn, you'll notice it's only going to turn at 10 degrees. You'll notice it's turning at 10 degrees of bank. If I put it back to auto, it'll go to 15 to 25, depending on your speed. If I were to increase this, okay, now it would probably turn 25 degrees because it's more of a heading change. If I increase this speed all the way up to, let's do that now. Increase that speed all the way up as far as it goes, which is 399, you'll notice that the bank angle will start to lessen. And now it's showing 25. We're in auto. But it'll start to reduce here. As that speed increases, it'll start to reduce. And it'll go to about 15 degrees. Now, I got 399 knots selected. Will it overspeed? No, because you have protection. You'll notice the protection's already kicking in. The auto throttle is starting to reduce the thrust to keep you at the max maneuvering speed, which is the top of the yellow boxes right here. So even though I'm calling for 399 knots, it's not going to let me get there. It maintains this speed and says, I'm not going to let you get to 400 knots. Now you'll notice the FMAs don't say that it's doing anything. There's no enunciation that tells you that it's doing speed protection. But it is. It's doing speed protection. You have high speed protection, you have low speed protection. So if I take the speed and I bring it all the way down to 100 knots, the system is not going to let me get to 100 knots. It's going to keep me at a minimum speed based on flaps and gear configuration as well. Right now the flaps are up, the gear's up, so it's going to keep me at the minimum maneuvering speed for flaps up. Now that's going to be below the up bug, and that's not where we want to be, but it's a safe speed. We're not going to stall because of it. Let's keep the heading bug turning. Again, you'll notice as the speed decreases, the bank angle will increase. It's at 25 degrees right now. So if I'm flying the airplane, I want the speed to be above the up bug or at the up bug without any flaps, but not below the up bug. And that's where I would want to be. But in this case, the minimum maneuvering speed is the top of the amber band. That's where it's going to allow the speed to go. But you hear the power coming up right now, and it's going to keep us pretty much at this upper point of the yellow arc, or the yellow band. See, it does allow us to get below the up bug, but it's still a safe speed. It's a margin above stall, and it's keeping us at that safe speed. And it's whatever it is. I forget if it's 20% or 30% above stall, but it's keeping us a certain percentage above the stall speed. So you have high speed protection, you have low speed protection, and you have flap limit protection and gear limit protection as well. So if I take the flaps and I go to flaps 1, you'll notice that the speed is going to be allowed to decrease now because I've got the leading edges coming out. The mid-span and the outboard leading edge flaps the mid-span and the inboard leading edge flaps are coming out. And so now it will allow me to get to the upper portion of the minimum maneuvering speed, but below the 1. And again, would I want to get this slow? No. I'd want to be at 1 or above. 1 or above, but not 1 knot below this. But again, the system says I'm keeping you a certain percentage above the stall. And so the auto throttle is controlling the speed. So the auto throttle is the one to protect you right now. Now, if we were to go into let's go into flight level change climb. Let's go to 14,000 here. We'll go flight level change. Okay, now the elevator is pitching to maintain the speed. And again, we're calling for a speed of 100 knots. Well, it's not going to let us get there. The pitch is not going to let us get there. It's going to keep us right at the top of this amber band, in order to protect us. But again, the auto throttle's not doing it now. The pitch is, because it says speed. Speed is a function of pitch, and the pitch is keeping us at the top of the amber band. Let's go altitude hold. Now the auto throttle is controlling speed, and the auto throttle will power back to keep you at this amber band. So it just depends what's controlling speed here. Is it thrust or is it pitch? If it's pitch, then pitch is going to control the speed. If it's thrust, then thrust is going to control the speed to keep you at the amber band. Okay, now let's bring the speed up to, let's go up to 300 knots. We're going to leave the flaps at 1. The limit speed for flaps 1 is 280 knots. So you'll notice the power is already coming back to keep us at the limit speed for the flaps. So again, we have protection. I'm calling for 299. It's not going to let us get there. It's going to stop at the boxes, because that's the flap limit speed for flaps 1, which is 280 knots. So it's going to keep us at 280. Eventually it'll kind of creep up here, but it'll keep us right at the red boxes, or just below it. Okay, so again, you have high speed protection, you have low speed protection, you have flap limit protection, and you have gear extend protection. If I brought the gear down, then it would keep us at 320 knots, and not to exceed that with the gear extended. If I bring the flaps up right now,
Flaps up.
okay, now it'll be allowed to increase to 300 knots. So those are our speed protections that I wanted to cover, in addition to the other stuff. So now we'll get back to the, we talked about the roll modes, heading select, heading hold, and LNAV. We talked about the speed protections. Now we're going to talk about the pitch modes. So the first pitch mode we'll talk about is vertical speed. The vertical speed mode has its uses, like we said in the briefing, but they're limited. One problem with vertical speed is I could open the vertical speed window like right now, and it shows that the current vertical rate, which is 0. Okay, I could spin this window up to, let's put it up to 15,000, 16,000. I can go vertical speed down 500 feet a minute, and the airplane is perfectly happy to go down at 500 feet a minute away from the altitude window. You notice it's not going toward the altitude window now, it's going away from the altitude window. So if I kept it like this and I just passed out, the airplane would just continue down at 500 feet a minute until it hit the ground. There's no protection here. Now you'll notice it is holding the speed. See that, again, flight level change or VNAV, just to enunciate this, flight level change or VNAV will never go away from the altitude window. They always go toward the altitude window. Whereas VS is happy to go away from it, doesn't care. Because you're holding a vertical rate, doesn't care whether it's going toward the window or away from the window. And that's not exactly safe if you're not going towards something you're going to capture. Now you'll notice it's holding the speed nicely. All right, the auto throttle is in speed. The pitch mode is vertical speed. It's pitching for 500 feet a minute. Notice the little magenta tick mark here, representing that 500 feet a minute. And the auto throttle is doing a nice job of holding 250 knots. Now let's go to 1,000 feet a minute. Now you notice the vertical rate is increasing to 1,000 feet a minute. And again, the auto throttle is going to power back to keep you at 250 knots. It's controlling the speed. Now you notice it's having a little bit of a problem holding 250. but it'll get there. It'll get it at 1,000 feet a minute. You'll see it's coming back. Now the speed's starting to come back. 253, 252. So it's, if you use a vertical rate that is reasonable, it will maintain, the auto throttle will maintain the speed. There's no problem. If you start to use a vertical speed that's not reasonable, so let's start to increase this vertical rate. Now let's go down to 2,500 feet a minute. Okay, now it's going to have a problem because the pitch will pitch for 2,500 feet a minute, but the auto throttle comes back to idle. That's all it can do is go back to idle and look at the speed. The speed's increasing. Now, yeah, we could use speed brake and try to help it, but we're still not going to maintain that speed. And the problem is if we spun this all, well, actually, we'll leave it at 16,000. The airplane would continue to accelerate, continue to go away from the altitude window, and the airplane will overspeed in this case. There's no protection in vertical speed. And that's part of the problem. There's no protection in vertical speed. So if you were to get an overspeed, it would overspeed. If I increase this vertical rate to 4,000 feet a minute, it'll be happy to overspeed the airplane. Okay, when I get to 7,000 feet, I'm going to push altitude hold. Altitude hold is another pitch mode. So when I get to 7,000, I'll push. Now you notice the speed's kind of stabilizing here. It's not really increasing anymore. I gotta do something about this mouse. When I get to 7,000, I'm gonna push altitude hold. There's 7,000, I push altitude hold. The airplane will now level off very smoothly. It'll pitch up and it's gonna go back to where you push the button. So I pushed it at 7,000, that's where it's gonna go back to 7,000. So unlike heading hold, it will go back to where you push the hold button. Exactly where you pushed it, pretty much. Now you notice again, the auto throttle is in the speed mode, so it's going to hold our speed at 250 knots. Now you can see I pushed it, well, let's see where it settles. I pushed it pretty close to 7,000, maybe 20 feet below. Spin the heading bug around here back toward the airport. Okay, so you can see I pushed it a little bit below 7,000. If you were to let's bring this down to 5,000. We'll go vertical speed 1,000 feet a minute down. Now let's make it 3,000. Again, look at the speed take off because we're calling for something that's not reasonable. Now when I get to 5,000, I'm going to push altitude hold, but I'm going to keep pushing it.
1,000 feet below.
Now all it remembers is the last push, so when I get to 5,500, I'll push it. So here comes 5,500. Push, push, push. I pushed it 3 times. Now where's it going to level off? It's going to level off at the 3rd push. I pushed it 3 times. It's going to level off right at that 3rd push. I think I got the 3rd push. So right around in here is where it's going to level off. So it's the last push of the button that it remembers as far as where it's going to level off. So if you wanted 5,000, again, we could then go down to 5,000. This would be a good case for vertical speed. You're at 5380, you want to get to 5,000. You know, it's a small change. I just want to use vertical speed to get down there. That would be a good, reasonable use for vertical speed. I want to hold a particular vertical rate to make a small change like this. Okay, so vertical speed has its uses, but they're limited. And again, the big things are no speed protection. They can fly away, it can fly away from the altitude window. But there are times we do use it. And especially if you want to make some small changes like climbing at 1,000 feet a minute and things like that, you can use it. But as a normal pitch mode, we don't use it. That's the bottom line. As a normal pitch mode, we don't use it. What we do use is flight level change in VNAV. So let's say we want to climb from 5,000 to 8,000. And we're going to do it in flight level change. And we want to do it at 250 knots. So like we talked about in the briefing, it looks at the fact that you're at 5,000. You want to go to 8,000. That's a 3,000 foot change. It attempts to get you there in 2 minutes. So to go from 5 to 8 in 2 minutes, it would give you approximately 1,500 foot per minute climb rate. And you'll notice that when I push flight level change, it's going to say thrust, flight level change speed over here for pitch. Thrust means it's a variable thrust. It can go from where it is right now up to the reference, which is 107.6. Why did it go into go around? Because we had the flaps out. Remember, we went flaps 1. As soon as we did that, coming at flaps out of up, it went to go around. Now, if we wanted to set it back, not that we need to, but if we wanted to, we could come in here and go to our thrust limit page, and we could change that back to where we want it. Let's say cruise, or so we'll change that back just for the heck of it to show you. But the reason it went to go around is because I went to flaps 1 when we were demonstrating the altitude, when we were demonstrating the speed protections. Okay, so we're going to push flight level change. Watch the enunciations: thrust, flight level change speed. The elevator is pitching to maintain the speed of 250 knots. The auto throttle is going to give you a rate of climb proportionate to the change. So if we're going from 5 to 8, that's a 3,000 foot change. It'll climb at 1,500 feet a minute, approximately. Not exactly, but again, it's trying to get you there in 2 minutes. And look at the thrust. It's nowhere near the reference. It's nowhere near the reference. It's a variable thrust to give you that climb rate. Now, if I were to move the thrust levers, I'm going to move the thrust levers now. And notice that the pitch, look at the auto throttle enunciation when I do this. It goes into hold. I just pulled my thrust levers back. And by doing that, I'm controlling the rate now directly. So if I want to climb, let's say at 500 feet a minute, I'm going to try to set a power for 500 feet a minute. Hold means that power has been removed from the servo motor. So when I move the thrust levers and flight level change, I'm telling the system, I want to control the rate, not you. And so I could pull the power back and decrease that rate of climb if I wanted to. I can even go down. Watch, if I pull the thrust levers more, watch what happens to the vertical rate. It's going to 8,000, but it's not now. It's going down because I've reduced the thrust. And it's pitching to maintain the speed, to keep the speed at 250. So if I add power, it's going to pitch up, and it's going to hold that speed with the elevator, with the pitch. And again, it's going to settle here at what, 700-800 feet a minute. Now, if I want to give it back to flight level change, from hold back to thrust, all I need to do is take this arm switch and go off and back to arm. And then it'll go back to thrust. And now it's going to figure where you are, where you need to go, and what rate I need to give you. So it's probably not going to change too much because we're, almost 1,000 feet from 9 or 8,000. But I've given it back to the system now. So anytime you move the thrust lever, it's going to go into hold, and then you can control the rate instead of it. But again, if it's controlling the rate, it's going to control to half the magnitude of the change to get you there in 2 minutes, basically, if you want to think of it that way. Now, flight level change will end. I'm going to take the power here and push it up just to get us up there. So you notice it goes into hold. Rate increases. Flight level change will end when you capture the altitude of 8,000. So you can see L, you can see speed, and now flight level change is gone. We got speed light bar, we got hold light bar. But again, how do we verify that we're in speed and altitude hold? We look here. We don't really look here, even though we could, but that's not where we look. We look here. Speed L. Okay, now flight level change descent, let's go from 8 to 5,000. And we'll go flight level change. So we got thrust, flight level change, speed. The power is going to come back to idle. It doesn't care now that we're going 3,000 feet to 5,000. It doesn't care. It just goes back to idle thrust. The elevator will pitch to maintain the speed of 250. It'll go into hold when it reaches idle, basically. Power is removed from the servo motor. And now what rate of descent is the rate of descent you have? So it doesn't care, you know, that there's a 3,000 foot change here. It just goes to idle thrust. Now, what if you want an increased rate of descent? Like we said in the briefing, you can either increase the speed, but in this case we can't because we'd be violating a reg of 250 below 10. But if we did, let's just do that anyway. I can reduce the speed and that will increase the rate of descent. And you can see the rate of descent increasing because I increased the speed. So that's one option, but really below 10 I can't do that. So the only thing I could really do is extend the speed brakes if I wanted more of a rate of descent. You know, if I'm descending to 5 and ATC says, hey, can you expedite down to 5 for me? Well, yeah, I could add some speed brakes. That's about all I can do. You know, so I'll go ahead and do that just for the heck of it. I'll extend the speed brakes. I'm extending them right now. You'll see the rate of descent increase. So now our rate of descent is 2,000 feet a minute because I got the boards out. And that's about all I could do. You know, I can't increase the speed, but I can give some speed brakes. And if he doesn't like that, then, you know, unable. I'm unable to do any better than that. Yeah, here's the box again, the white box and the white box. Usually that comes on 900 feet before it goes out at 300. But there's different options for this so that can change a little bit. Okay, now I'm going to retract the speed brakes. Okay, so a flight level change climb and a flight level change descent, they're more your friend than vertical speed is. Do we use flight level change in a climb? Not that often, because usually we're in a VNAV climb. But if it was a short climb segment, you might want to use vertical speed or flight level change. You know, if you're like going 2,000 feet somewhere, you probably want to use something that's going to be less than balls to the walls VNAV, where it goes right to the reference thrust. So they're available if you want them, but most of the time we stay in VNAV in a climb, because most of the time you're climbing your cruise altitude. You're going to make big chunks, you know, big changes. But VS could be used if it's reasonable, and you make it reasonable, or flight level change can be used because you can control the rate if you don't like the rate it's given you. But flight level change is most used in a descent. That's when we use it mostly, when we come out of VNAV and ATC starts yanking us around for vectors for the approach. Then normally what we'll do is go into flight level change. That would be normal. Because now there's no economy anymore. It's a staying on the profile. We're off the profile. ATC says descend and maintain 3,000, and they want you down now. And so we go flight level change. The other pitch mode that we'll talk about, and we talked about it in the climb a little bit, was VNAV. And we won't talk about that so much now because there's going to be plenty of lessons where we do VNAV. But VNAV is the other pitch mode, and we said it's very similar, very, very similar to flight level change. And we'll do just one of these. Let's climb to 8,000. We're going to do it in VNAV this time. I'll push VNAV. We get thrust, rev, VNAV speed. We kind of screwed up the profile here, so I'm going to have to reduce the speed to 250. And notice the thrust goes right to the reference. It doesn't care about the magnitude of the change. It's going right to 99.2. Thrust reference. The elevator's pitching to maintain the speed of 250. And look at that rate. We're going up pretty good. So if you had a small change, VNAV might not be the best
1,000
option.
feet to load.
Because it's climbing at 5,000 feet a minute here, from 7 to 8. And now you'll notice we came out of VNAV, we're in VNAV Alt. And notice when you're in VNAV Alt, the light bar does not illuminate here. Notice when you're in speed, the light bar does not illuminate here. Anytime you're in VNAV, like we are right now, these light bars are not going to illuminate for altitude hold and the speed. Even though we are in VNAV Alt and the auto throttle is holding the speed, the light bar doesn't illuminate. And that's why we always look here. We never look really here. This is what we actually have, what the FMA says. Okay, one more thing before the approach. Let's look at the EFIS control panel and the EICAS control panel. This is the EICAS control panel. This is the EFIS control panel. On the EICAS control panel, we can select the various synoptics that we can get on the secondary EICAS. We can go to engine and get the engine display. We can go to status and get the status display. We can go electrical and get the electrical synoptic, or the gear synoptic, or the door synoptic. Whatever we want down here on secondary EICAS, we can get it through here. We can also recall and cancel messages, and that's the EICAS select panel. Normally we operate with the secondary EICAS blank. Some airlines do operate with it on. It's just, you know, it's up to the airline. Most operate with it blank. And this is the EFIS control panel. And you've got the things we talked about, the baro radio switches, the map VOR approach plan mode, the range switches, the VOR and ADF, the baro in inches or hectopascals, and of course you have your map switches. You can bring the weather radar on, like we had it on, which the FO does in this case, since I want to be in terrain, since I'm flying. You can bring stations on. That'll bring all the stations in the database for the selected range on. You can see as I bring the range up, I get more. If you're above 80 and I think it's 80 and above. If you're 80 and above, if you're 80 and above, these will all be high altitude nav aids. If you're below 80, they could be low and high altitude nav aids. So if I went to 40, whatever I see in this range, it could be a low altitude nav aid, it could be a high altitude nav aid. So if I go to 320 here, these are all high altitude nav aids. No low altitude nav aids. These are all high. And it makes sense because the range is high. Waypoints, if you push the waypoint switch on, I'll push the station switch off. I'll bring the airport switch off too. And if I just bring on the waypoint switch, you'll notice there's no waypoints displayed if you're 80 miles and up. You have to be in 40 miles or less to get waypoints. So now you'll see the WPT down here. It didn't happen when I pushed on 80 miles. You didn't see that WPT down here. But once I was in 40 miles or less, then you'll get all the waypoints for the selected range. So these would be all the waypoints in the database displayed as a triangle. Let's turn. Let's turn the airplane. Okay, so that's the waypoint switch. Turn that off. Airport, we said what that would do is select all the airports in the database for the selected airline configuration. So again, the airline will specify that that's an airport with a hard surface runway greater than 8,000 feet in length, or whatever they choose. In this case, it's coming up with Tacoma and Boeing Field and whatever this airport is. It's coming up with a couple airports, but again, it's based on the criteria the airline sets for it. It's not a grass runway, it's not a small runway. It may be an airport that does not have emergency facilities. It's just a hard surface runway greater than a certain length. But it may be somewhere that you could put the airplane down if you had to. But there may not be emergency facilities there to help you. Data will show the ETAs. Bring the range up, you can see here, Painfield at 1900 Zulu. And if there's any altitude restriction, that'll show up when you push data. Position, if you bring a range all the way down, will show the 3 IRS positions. You can see it right here. There's one IRU, here's another IRU, here's a third IRU. And this little thing that looks like a little UFO, that's the GPS position. And the GPS position is right at the tip of the triangle, because the FMC position is based on GPS right now. The 3 IRS positions will combine into one to make an FMC inertial position, and that's going to be probably different than the GPS position, but the GPS is more accurate, so it makes the FMC position the GPS position. And there's a bias between the position of the GPS and the 3 IRSs. Now the 3 IRSs never update. They never update themselves. But the FMC inertial position can update itself based on the 3 IRS positions combined into one and then updated by DME, or in this case GPS. And the GPS becomes the FMC position. And there's also some raw data radial lines going out here to VORs that are on the NavRad page. In this case, it's going to Seattle, and it's going to Payne. And those are nav aids that are being found on the NavRad page. Yeah, let's see. There's Payne. Payne is being route tuned, and Seattle is being auto tuned. So those are the nav aids that we have here. And then if we take that off, and then we have terrain, and that'll show the terrain in the database. And it'll show the highest and the lowest terrain for the selected range. So in this case, 1,900 feet to 3,600 feet. The highest terrain is 3,500 feet right now in this range. Bring it up, that's going to change. And notice now it's 5,700 feet. There is high terrain to the east of us here. And you also have down here on the CDU, if you go to the menu page, you have the EFIS and EICAS control panel. And there is a control panel off-on switch here. Now some airplanes have this, some airplanes don't. It just depends on your airplane. If you don't have it, then the only way this activates is if this fails or this fails. If the captain or the FO EFIS control panel fails or the EICAS panel fails, then you're going to get the select prompts down here. Say select, select. And then you can get in here And anything you can do up here, you can do down here. So, or you can turn it on. In this case, I can turn it on, and even though they're not failed, if I turn it on, I'll get the select prompts. And I've taken control away from this right EFIS control panel now. That's why you get the message here, because I've taken control away. This is the message you would get if it failed. But in this case, it didn't fail. I just turned it on. And now if I go to the EFIS control panel, you'll notice that anything I can do here, I can do, anything I could do here, I can do here now through the CDU. So again, you'll notice if I want to go to the VOR mode, I can go VOR mode. If I want to go to centered mode, I can go to center mode. If I want to go back to plan mode, I can go to plan mode. If I want to go back to map, I can go back to map. If I want to go to expanded, I can go to expanded. If I want to increase my range, or let's decrease our range, I could go range decrease. And it's at 40 miles now, it tells you right here. If I want to set my minimums, or radio or baro, or altimeter setting, I can do it from here. Same thing with and notice there's two pages here. There's a control page and an options page. If I push options, it'll go to the EFIS options page. If I push control, it goes back to the control page. So there's two pages here. An option page, and that allows me to, again, select these things like flight path vector and waypoint stations, all your map switches. Or I can go to control and select things here. Now if I go back to menu, and I turn that off, now these go blank again. And now control is through here because these are working. If I turn it back on, and I go to the EICAS control panel, anything I can do up here, I can do down here. So again, if I want to go to the engine page, I can go to the engine page. If I want to go to the fuel synoptic, I can go to the fuel synoptic. If I want to select the status page, there it is. If I want to cancel that message, I can cancel it. If I want to recall it, I can recall it. Notice there's two pages here too, a mode page and a synoptic page. So if I push the synoptic page, again, it gives me more choices. Electrical, ECS, hydraulics, and doors. Go back to the menu page. And again, I can turn that off, and then it will revert back to what's operating, which is these. But again, if you don't have this, then the only way you can get in there is if these panels fail. And if those panels fail, then you'll get the select prompts automatically. We're going to set up for the approach. Back in the Boeing field. So we're going to go departure arrival. It's going to take us to the Boeing field arrivals page, and that's the page I want. Now, if that's not the page I want, notice you have an index down here. And you could go to index, and then you'll have route 1, route 2, and other airports that you could look at if you wanted to. But this will tell you if if the logic didn't switch over and you had a destination, let's say Moses Lake, you could then select the arrivals from Moses Lake. If pushing depart doesn't give you what you want. In this case, it does. It gives us what we want, which is Boeing arrivals. So we're going to select the ILS 148, and we're going to execute that. I could select this transition here, but we're going to do it manually. I'll execute that. And then what I can do is, that's all I need here is just select the approach. I don't need a star. I just need the approach. ILS 148, no transitions. And now I'm going to go to legs page. And here I have Seattle. I have a discontinuity. And then I have a Sagi at 2200, Togay at 1600, and the runway, and then the missed approach on the next page. Okay, so let's say I'm being vectored for the ILS approach right now, and we're going to pick up a heading on 180. And let's go ahead and descend to 4,000. And again, we have nothing programmed for VNAV, and there's no economy to using VNAV, so we're going to use flight level change. And we'll keep the speed at 250 for now. Now, since we're being radar vectored, the first step of that Y pattern was select the departure page, depart page. We got the arrivals, we selected the ILS, and there is a Seattle transition there, but we don't want that. So we're going to execute that. And then we go to the legs page, and that's where we were. So now what we want to do is, since we're on radar vectors, we want to extend a line into the waypoint we think we're going to go to. And so in this case, I'm going to go back to the expanded mode. And you can see what we have here now. We're going to come in, it looks like outside of Asagi. There's Asagi, Toge, and the runway. I'll bring the range down a little bit if we can see it. No, I can't see it yet. So what we're going to do is we're going to extend a line into Asagi. And the way we do that manually is we could bring this Asagi to the scratch pad, bring it to the top over Seattle, because I want it to be the active waypoint. And then you'll notice that it goes direct to Asagi. That's not what I want. I want the intercept course into Asagi, which is going to be this 134 course right here. So I'm going to type out 134 and stick that in the boxes. What that does is that extends a line so that I know where the extended center line is into Asagi. So no matter how he vectors me, I have a reference to where that extended center line is. And I'll execute that. And now you see it goes magenta, and I have a reference to where that is. Next, we're going to go to NavRad. We'll check the ILS 110.9, 135. And that's good. And we'll get the approach chart in a second here and look at it. And then we'll go init-ref is next, and we'll select flaps 30 speed, which is going to be flaps 30, 151. So you notice here I went depart, selected the approach, legs, solved the modification by bringing Asagi to the top, drawing a line into Asagi, and then putting the 134 course in the intercept course. I'm done with that. I go to NavRad, check the ILS. We'll check it against the plate, but I know that's what it is. 110.9, 135. I don't need anything in the VORs. I can leave them route tuned or auto tuned. I don't need anything in pre-select right now. And then I'll go init-ref and select my flap 30 reference speed. So again, it's depart, legs, NavRad, and init-ref. It's a Y pattern.
1000 feet to load off.
And then I can set my auto brakes, or I can tell the pilot flying what I want, or pilot monitoring what I want for auto brakes. It's going to be 2 for auto brakes. And then I can set my minimums. Now let's go look at the chart though, before we do that. Okay, so here. Okay, so the minimums are going to be 308 for the DA. Go back here. So I set this right here. I just set the barrel by making sure it's in barrel. And then, as you guys, most of you probably know this, but I'll do it again. I'm setting 308 in here on the PFD. And again, you may have 10-foot increments, or you may have an option to change that. But we can set 308 directly here. And that's the barrel minimums, and that's going to be a 290-foot height above touchdown. Okay, so we'll brief the ILS approach. Okay, so briefing will be the ILS runway 14 right. Localizer is 110.9. Final approach course is 135 inbound. We're going to be crossing Toge at 1600. Looks like Asagi at 2200, and then going down to a decision altitude of 308 feet. That's a 290-foot height above touchdown. The minimum sector altitude, the highest terrain is to the east, to the north and to the east, and slightly to the south at 6,400. To the northwest is 3,400. To the southwest is 2,200. we need 4,000 RVR, or 3/4 of a mile for the approach, category D. We're looking for a PAPI on the left and a Mauser approach light system. In the event of a missed approach, it's going to be climb on the IBFI southeast course to cross OCZ, 3.9 DME from the IBFI, which is a localizer DME, at or below 1500, then climb on the IBFI southeast course to the 9 IBFI localizer DME, then turn right on heading 206 and outbound on the Seattle radial 168 to 5000 to CDIG, which is 25.8 from Seattle, and hold. And it does have a note there: descent to at or below 1500 may be required when executing an early missed approach, because you have a restriction there of 1500 before you turn. So if you look at our missed approach, you'll notice that we're going to the runway, and then after that we go to OCZ. It's 1500 below, so that is a restriction. Then it'll be a 135 track to intercept the 104 to Blaco. I don't have the same missed approach here as the plate shows. So again, that's the missed approach. The missed approach will be, says out to CDIG, but we're going to modify it to Blaco just for the purposes of time, because this is not a green.
Descent checklist. Recall.
Check.
Auto brake.
2.
Landing data.
VREF 30151, minimums 308.
Approach briefing.
Complete.
Descent checklist completed.
Thank you. Approach checklist.
Approach checklist. Altimeter.
294 inches.
Approach checklist completed.
And we would cross-check each other's altimeters to make sure they're set properly. Okay, so we'll resume. We'll say ATC gives us a heading 160, vectors to intercept the localizer, and he'll give us approach clearance in 10 miles. And he says descend and maintain 2,200. So we'll go ahead and descend to 2,200. We'll set 2,200 in here, and we'll go flight level change. And I'll bring my speed back to the up bug now. Now, I can be in legs. The other pilot would probably be in progress. And that way I can see my total distance to the airport, 17 miles. And so from Asagi, I'm 9 miles. So ideally, I want to time it so that I'm at flaps 10 when the glide slope moves. So I can go flaps 1 right now.
Flaps 1.
And we'll set the speed. And again, where do we set it? We box the 1. Now again, some airlines will set it there.
Localizer alive.
Which is 5 units, or 5, we'll go ahead and arm the localizer, clear for the approach. Localizer capture.
1,000 feet to load.
So we'd say a localizer alive, a localizer capture. Some airlines set it right there, 5 knots higher. Some airlines set it right here, 10 knots higher. Boeing, we put it right on. Procedures, Boeing procedures. Let's go to flaps 5.
Flaps 5.
And we'll put it right on the 5. And we can bring our range down a little bit here so we can see. Let's go flaps 10.
Flaps 10.
And we always think in our head, set speed. Because anytime the flaps move, we want to move the bug. Now, we could also keep the speed up. You know, if ATC said, you know, maintain 200 knots until further advised, then we could keep the speed at 200. But in training, typically we keep it at the current flap speed. Okay, we captured the localizer. We're clear for the approach, so we'll arm the approach. Now you can do that all at the same time. You can arm the approach and then intercept the localizer and then the glide slope, as long as you have proper sensing. In this case, I armed the localizer first, it captured, then I armed the glide slope. That's okay too. That just prevents a false glide slope capture by doing that. But if you see the proper displacement, then you're all usually good. Okay, glide slope live, so we'll go gear down, flaps 20.
Gear down. Flaps 20.
And we'll set speed. I'm also going to arm my speed brake. So you see that right here. Let's see, the final approach fix is Toge. So the final approach fix is Toge, so that's where we're going to make the call, the first call that we do. Here comes glide slope capture, so we'll go to flaps 30.
And flaps 30.
And again, in my head I say set speed. I'm going to say rough +5, no additive. And that would do the landing checklist.
Landing checklist. Speed brake.
Armed,
Landing gear.
down,
Flaps.
30.
Landing checklist complete.
Thank you. Glide slope capture will set the missed approach altitude. Even though I'm not sure what the missed approach altitude is, or the missed approach is. So we'll set 6,400. We'll use Blaco here in the CDU. Got two conflicting things here. We'll set 6,400 for a missed approach to Blaco. It's on the in the CDU. Here comes Toge at 1,600. There would be a call from the pilot monitoring, and we check that that cross is at the proper altitude on the glide slope. Next thing is going to be to 1,000 feet. We're going to call this 1,000 feet, instruments normal, missed approach altitude set. We're checking that it's set at that time. And again, assuming this is the proper missed approach and the proper missed approach altitude, we'll call it out. So here comes 1,000 feet, instruments normal, and missed approach altitude set. Next call is going to be at 500 feet. We're going to call out 500 feet, land 3. What we see on the autopilot flight director engaged status. Now notice all 3 autopilots are engaged at this point. They engaged at as soon as we had 1,500 feet. As soon as we saw land 3, all 3 autopilots were engaged. Or, yeah, they were armed when we pushed it. They're engaged at 1,500 RA. So there's 500 feet. Land 3, if there's a crosswind, this is where the runway alignment would start to occur.
Approaching minimums.
The approach lights are in sight, the runway's in sight.
Minimums.
Landing.
200. 100. 50.
There goes flare.
30.
25 feet we get idle.
20.
At 5 feet we'll get rollout.
10.
And notice flare is going to disappear as soon as we touch down. Reverser's normal. Speed brake up. We'll start to come out of reverse.
60 knots.
Bring the auto brakes off.
Auto brakes.
And to get off the runway, we have to disconnect the autopilot. And now we'll go ahead and vacate the runway. And of course, he would have cleared us to land and all that. And then he would have said, you know, turn right at whatever it is, kilo, and contact ground point 9. We'll clear the runway. And then we'll call ground control, and he would give us our clearance back to the ramp. And then at that point, and as long as I know where I'm going, and we're both heads up and heads out, we have our taxi diagrams out, you know, at that point, when things are kind of calmed down, I know where I'm going, we're on our way, I'd say after landing procedure. And then all I have to do, again, is to, as the captain, is to bring the speed brake up. We'll go ahead and look at that. So we'll bring the speed brake up. I'm going to bring my weather, well, in this case, terrain, because I like to be in terrain. Because in order to do this training, I'd rather be in terrain. I'll turn the terrain off, and then the auto brake's off. Those three things. That's the captain. I'll stop the airplane here. So he does just those three things after landing procedure. Then we're going to go upstairs. And the FO would start the EPU. Engine anti-ice, if we had icing conditions, we could turn it on. Because it doesn't work on the ground, even in auto. So we would turn it on if we had icing conditions, but we don't, so we're going to leave it in auto. And we're going to turn all our lights off. Leave the taxi light on, we'll turn the strobe off. And then we'll come down and turn the, he's going to bring his weather radar off, the FO. No, we had it off because we were fooling around with it. It's off. And he's going to bring the flaps up. He's going to make sure the captain put the speed brake down. While he's doing this, he kind of looks over there just to make sure it's down. And he'll come over the transponder and go to transponder. Like so. And that would be the after landing procedure. We'll say we're pulling up to the gate area now. I'll bring the airplane to a stop. I'll set the parking brake. If I can. Parking brake set. And then I'll call for the shutdown procedure. Shutdown procedure will come upstairs. We'll start with the APU. We'll bring APU generator 1 on. We have to select it on. It's not automatic that it takes over, so we have to select it on. Then FO will go to number 4 to aux. Number 1, 2, and 3 to off. As soon as he does that, that's the cue that I can shut him down. So I'm going to come down and bring number 1 to cut off, 2 to cut off, 3 to cut off, 4 to cut off. And then I'll come up here and turn my flight director off. That's about all I have to do. That's the Boeing procedure. Now, I really don't like doing the flight director here. I'd rather do it as part of the after landing, but that's not the Boeing procedure. The flight directors don't do you any good once you're off the runway, so I would put this as part of the after landing, but Boeing has it as the shutdown. Personal opinion, anyway. FO is going to come down here and turn the seatbelt sign off. Now he goes back upstairs. And now he's going to go through his flow. So he'll get the fuel pumps. And let's say while we're doing this, we either get a call or we get a signal that the chocks are in. And if the chocks are in, and I know the chocks are in, then I'll go to off. Here's the FO. Oops, I'll go to off. And then the captain will release the parking brake if he wants to. So I got the fuel pumps. I got the beacon off. I'll come downstairs and get my flight director off. It kind of did turn off when I turned the captains off. These turn on. Sometimes these turn off together, just the way it's set here. I'll turn it off now. I'll go to status page because I'm checking for any status messages to write up. And then I'll go to the transponder to standby. And if I'm a real nice guy, I'll put in 2000 for the next crew for a VFR squawk code, indicating you don't have a clearance yet. And then I'll call for the shutdown checklist. So shutdown checklist.
Shutdown checklist. Hydraulic panel.
Set.
Fuel pumps.
Off.
Flaps.
Yeah, let's go down there and check it. Just make sure. Up.
Parking brake.
Released.
Fuel control switches.
Cut off.
Weather radar.
Off.
Shutdown checklist complete.
Okay. And then I'd call for the securing procedure, assuming we're securing. And again, that would be to bring the IRUs off. Emergency exit lights off. Aft cargo heat off. And packs off. And then I'd call for the securing checklist.
Secure checklist. IRSs.
Off.
Emergency exit lights.
Off.
Packs.
Off.
Secure checklist completed. Thanks for the flight.
Okay, and then if we wanted to power down the airplane, we'd go to the electrical power down procedure. And again, the electrical power down procedure would say to bring the, again, before I completely terminate, I turn all my lighting down. And then I would go ahead and turn the APU off, the standby power selector off, and then we'd start our time for 2 minutes. And when 2 minutes is up, then we'll turn the battery switch off if we had to power it down completely. And then you'd be back to a dead airplane, basically, as you can see from that picture. Okay, that completes Ftd Pc-Fs number 2 flight. As I said, we will continue to speed things up as we go, and eventually we won't do the cockpit setup except what's necessary in order to maintain continuity in these lessons as we go to point A to point B. And I think on lesson 3, we probably do go from point A to point B, and we're not in the local area anymore. So again, the purpose of this lesson was to determine the roll modes, pitch modes, auto throttle modes, speed protection, setting up for the approach, 3 takeoffs to just note those things that we talked about on the takeoff. For you Patreon guys, look at the homework assignment. That's got kind of an abbreviated homework assignment. If you want to do, again, I suggest kind of flying the profile the way I did, and just kind of do some of those exercises. If not, do the homework exercise. And if you want to make a student video, you can make a student video if you are so inclined to do so.